Hello, hello. And welcome back. We are going to work on cast today again. Today I'm actually going to continue the refactoring that we started 2 days ago. And this is probably going to take a while. I did some stuff off stream though, but I'm just going to continue. So yeah, we're just doing the refactoring into functors and modules instead of just types. So I have I'm trying right now this approach. Here's my old new way, right? Module type debs. Back from pre-roll add. Hello, Nigel. Hi. So here's the new thing that I'm trying here. So I guess the only difference from this thing that I was explaining the other day is that instead of having B as a dependency, we instead have like dependencies of type dependencies. Okay. Yeah, let me actually like rewrite this from scratch, I think. This is the minimalistic example of what I'm trying to do. So, yeah, what we're doing is we are trying to declare two things. We're trying to declare A, and I'm trying to declare B, right? Both of those things have the signature like this, right? So A is a type which looks like that, right? But how do we know what a B here is, right? Well, here's what we do. When we declare the module A, we also declare the dependencies. Dependencies is something like this. We depend on module B, which must declare a type, right? So the signature of module A is something that has the dependencies, right? And B comes from the dependencies like this. And when we make B, we make using dependencies like so. Well, yes, in this case we also specify the printing and uniting, right? So for the dependency we need a print t unit, and we need unite t team, right? And we are going to have the same declared for ourselves. Yeah, there you go. So we have module A. We are going to have similarly module B. Module B depends on module A. In this case, I think we are also not going to use the like type underscore to prefix our variants, and instead just do that. And then in the end, what we're doing is that we create the recursive modules. First, we basically combine. So what we want is we want to create module A of type AS, and we want to create B of type BS, right? So we need to make A and we need to make B. This should be my dependencies, right? But the dependencies can basically contain all the modules, so we use all the modules as our dependencies. So we do specify what all is, and all is a thing which basically contains A and B. And we can pass this thing as a dependency to both A and B, basically. I think this is going to work, but I'm not sure. Right? So we construct this recursively with this thing. And this is the idea. Says deps.b. Yeah, over here it's deps a print, right? Wait, hold on. This module type is recursive. The use of recursive module A within the definition of module all makes the module type of all depend on the module type of A. Wait, what? Oh, yeah, okay. Yeah, because it's not exactly like this. We need to like say that this is the implementation or something, because I have two things that are called A right now. So we're going to say instead of AS or like A dot, we're going to say implementation AS, and instead of B dot, it's going to be impl B, right? So something like this is what we are going to do, and this seems like it is compiling, right? So there you go. Now this way we have a module A. So when we specify a module, which depends on other things recursively, we first specify the dependencies, then we specify the type that we are going to declare, and then we actually create this thing, and then we construct everything in the end at the same time, giving everything as the dependency to the constructor of everything. Feels a little cursed, but I don't know. Maybe this is the OCaml way. And we also basically expose, so I can say like this new way dot a dot t, let x this is equal to empty, right? Like I'm exposing the structure of the type, right? So I can construct this thing actually from the outside, and I can print it too, right? New way a dot like print x. So yeah, print. Can I say over here print end line a dot empty? B dot empty. There we go. Yeah, this works. Alright, so yeah, this is like the general idea of how we're structuring things. So our types are something like value, type, expression, pattern, all of these things. They all exist in their own modules now, like this. So like, for example, here's a pattern. Pattern also consists of multiple types. It has the pattern shape and then the pattern itself. So pattern itself depends on the pattern shape and the intermediate representation data, and pattern shape on the other hand depends on the pattern and a binding. So we can see there are recursive dependencies here happening, right? And then later over here I'm like constructing everything just like I explained a second ago, like this, but I did not finish this yet. So now let's see what's not finished. So yeah, we have the error messages now, which are 1 billion lines long because my signatures of the module okay, I cannot even scroll up this high to like see the beginning of the error message. Okay, but yeah, basically we have like this module called all, right? And this module contains everything, so it's trying to show me the signature of this module here, and it's like just very long. especially since the signatures, like for every like submodule contains the signature of the dependencies. So there's a lot of copy paste happening here. All right. But basically they are saying that value scope is required but not provided in yeah, so we are not giving the scope function in module value, right? So we are creating a value somewhere over here. This is a value, we're making it, here's our signature, and we're not having the scope. Scope is required for inference, right? So for inference in general, we require multiple things. We require scope, that's going to be var scope, I guess, since this is inferable one. Wait, do I need this to be inferable actually? We can see, yeah, like from the value I just require the scope and the unite function. Okay. Hello, Elemental Magic's card game. How are you doing? How's your card game? Are you still working on it? Okay, so over here I need to specify the scope, which must be t into var scope t. And what is var scope? It's not defined here, right? So it goes into the dependencies. So this the value must depend on the var scope. And then we have unite, which is t inference unite. Still setting up all the dependent types for the DSL. I thought you were writing Haskell. Doesn't Haskell doesn't have the dependent types, or does it have it now? Dependent Haskell. The future of dependent Haskell. If you add dependent types, you have production ready language with dependent types. It doesn't have it. You're doing Idris. Oh, I see. There's the roadmap. They're planning to add it, right? As far as I understand. Oh, that's the roadmap. Sounds complicated. All right. Is there any existing games in Idris? Are you the only developer that's just making game in Idris games with Idris? Idris Elba? Idris 2GL, there's graphic library for it. It's nice to have strict evaluation if you do dependently typed programming, otherwise you can have proofs that are invalid because they don't terminate. I see. Okay, so we need to provide the scope. What is the scope? So we say scope of value is value var. Well, I need to have like both of the scope of the type and the scope of the value var. So value var must also have a scope, which is t into var scope t. Oh wait, okay. So how do we? Okay, now we need to like unify these things though, in the dependencies. Okay, well, I'm going to be stuck now. Or I need to like figure out. I guess maybe var scope can be like declared first, and then we can say that type is this, and we can get the scope of a type and the scope of a variable, and we want for the scope to have like the common, which is t. So scope of a value is value var scope of value var, and type scope of a value type. Let's just say over here var and type. Right, so it's the common scope of these two scopes. Edwin Brady had a nice point about this. What is the practical difference between a computation that takes a 10 to the power of 10 to the power of 10 to the power of 10 years to run versus one that runs forever? It doesn't matter as a vanilla program. But if it's a proof, then it absolutely matters, because all you do is make sure it type checks. You're not going to run it. Yeah. Yes, proof is just the existence of a program. You don't run them, indeed. What does this has to do with laziness, though, versus strict evaluation? Because you don't evaluate in any case, right? You just need to, like, provide the proof, which is provide the program without evaluating it. Right? When you have, when you're writing proofs. Haskell has co-data anything everywhere, meaning all data includes infinitely large values everywhere. Doesn't play well with totality checking. Alright. That was some smart words that I don't understand. Maybe I can understand if I think about it for a long enough time. But I'm trying to do a refactoring here, and I want it to be done before New Year. Hopefully, we just have 4 days left, so that I can make actual progress on my programming language here. For example, data nat is 0 or successor nat is the natural numbers in the OCaml, and is the natural numbers together with the first limit ordinal in Haskell. First limit ordinal? What does that even mean? The limit ordinal. In set theory, a limit ordinal is an ordinal number that is neither 0 nor a successor ordinal. What does that mean? I like this picture, but I have no idea what this means. I'm not a math person. Omega lol? I know omega lol, I don't know omegas. What is omega? It's the smallest ordinal bigger than all natural numbers. You have infinite chain of successors. I still don't understand what this means. Isn't it the same in Haskell and in OCaml and in Idris? You have data nat is 0 or successor nat. Foo nat, yes. In OCaml you cannot have this. Every nat must be finite. But in Haskell nat can be infinite. Foo is successor foo. Oh yeah, okay. Yeah, you cannot do that? Okay. Can you not do this in Idris though? Wait, are you sure that we cannot do this? Let me try. OCaml playground. We can have type nat is 0 or suck of nat, right? we need to do that because we're doing OCaml. Okay. So can I not say let track x is suck x? I sure can. Right, this works. Does it not work? Tune exec, OCaml playground. Print nat x. Let track print nat unit is function 0 print new line 0 suck of suck x, I guess. Print nat x print new line suck. Like, I'm pretty sure. Wait, print end line or whatever. Right? Yeah, there we go. It's an infinite one. You can define the function, but you cannot pass the value it computes to anything else. In Haskell, you can say bar foo, and bar happily accepts an infinite chain of successor as her argument. This is because in OCaml we first fully normalize foo, which diverges, while Haskell you can pass foo directly before running foo. I mean, you still have the infinite one, right? It's just that in Haskell this doesn't evaluate over here, and this over here is lazy, which is only going to be be evaluated when we perform the pattern matching here, right? But in OCaml it's evaluated immediately, but it is still infinite. So what's the difference, really? In this example. You said I cannot do something, and then I just did it. I'm pretty sure we can do this in Idris too. Let's go to Idris. Temp Idris. Can I not do that in Idris? Do you declare data similarly? Nat is 0 or suck nat x nat x is suck x. Does that work? Ambiguous elaboration, possible results, main nat, prelude nat. Oh, wait. Because it already exists. Let's call my nat. Let's call it nut. And this works. It did not say that it failed the totality checker. Hello, bad cop. How do we make it fail the totality checker? Well, like, this is Idris. This is Idris 2 I'm using here, right? I guess when I try to print it, now Idris is going to actually hang infinitely. Can you pass this to a function? I'm pretty sure I should be able to pass it to a function. F, so yeah, F, not into, is that how you do unit in Idris? I'm not sure very, I only, tried a couple simple programs in Idris so far. So we just say fx, or can I just say f0 is this, and then f, and then f suck x is this, right? There we go. F x. Well, I mean, it doesn't terminate, it seems, still, right? Because, wait, why does it not terminate? Like, I'm not going into recursion here, right? How do you print something? because first evaluating x, yeah. So it does not, there is no totality checker though, it seems, right? It just evaluates this infinitely. Unless that's what you mean by totality checker. Evaluating it, is the infinite one. Right? Yeah. I'm actually wondering why OCaml then evaluates this properly. So evaluation is different in Idris and OCaml. But why? Isn't Idris also garbage collected? So like, we should be able to construct a recursive data structure like this easily. I'm probably having the same issue in my programming language though, because we are doing the same one. I don't really allow, I only allow like the types to be recursive right now, but I think I would be able to evaluate this. I see no reason for Idris not to be able to evaluate this. So because I'm having basically kind of the same thing. I got automated for typing out words that are already written in your editor. Yeah. So in my language we have similar like things. We probably will have dependent types implemented at some point. We have simple cases of dependent typing right now, but the way I would evaluate this is basically we don't evaluate this immediately, right? We don't call this function recursively. What we do is that we when we do this evaluation, we first say that x is equal to like something that's not inferred, then we evaluate suck x, which does not evaluate it recursively. It uses the existing not inferred value, because we can have not inferred values because we do inference for values too. And then after we evaluate this, we say that x is we evaluated this, you know, evaluated x is this, and then we say that x is equal to eval x, you know. So if you do it like these three steps, then you don't actually have infinite recursion. I'm wondering why is Idris not doing that. Yeah, we have like a simple indirection, which means that if we try to evaluate x recursively, we don't actually evaluate this. This is how we already break the cycles in the types. And like, why can Idris not do this actually is weird, because Idris is treating types as values anyway, right? So shouldn't, like, what's the difference between type not is 0 or suck not? Can we do that? Can we do this as a type, or is that not how you declare the type? Can you not construct infinite? Like, for example, right, like the normal one is like a tree. A tree is either like the empty node or a node of a tree and tree, right? So this over here, tree, how do we evaluate tree, right? If this is a type, right? Don't you just say that, tree type and the tree is this? So I guess the evaluation for types is after all different in Idris than for values, because you don't really like do that. They still have the special syntax which allows for infinite recursion but not for values. Yeah, but like they were supposed to be the same, right? So like you cannot say tree is a type like this. So they still have the distinction between values and types because of that. But I'm not having this distinction at all. So I literally do it like this. This is an expression which we evaluate when declaring the types. That's how my language works. So I see no difference between this and that at all. Values are distinct in that you normalize values, I guess. Well, but don't you normalize types either? Like, especially since you can have type functions, right? I don't know, make tree. Make tree is a function from, I don't know, type into type, right? That's how you do the generic types in Idris. So, so that's a function which you have to evaluate. So you have to normalize that when you treat types as values here. I don't see the distinction. I don't see why is it different. Anyway. Like, because, for example, how do you do higher kinded types, right? You still have, like, the... So that's why I'm saying that I am kind of having, like, lightweight dependent types, not fully implemented, but partially, because we do it for HKTs, right? If we have, like, a function that takes, like, higher kinded type and returns a type, right? So we say, like, make tree... make tree f is like f int or whatever, right? So this is the normalized value, f int, right? Until we know the value of f, which is no different from if this was not a type but something else. If this was int, and int, then this would still be like f0, and this is the normalized value of the of a value. So how is it different from types? I don't understand, but yeah, I don't know. I didn't really use Idris. All right, let's keep working. I just realized that Simon Python Jones, after authoring paper, let should not be generalized. Didn't just add let polymorphism to type. He also added a let polymorphism to kinds. Wait, is it after authoring the paper? Let should not be more generalized. What's the date of this paper? 2010. That's pretty old. So after that they added to Haskell the let polymorphism for kinds. All right, what do we have here? Unite. So how do we do unification? Unite for values. We just say span AB is var is depth value var unite span AB a var b var type is depth type unite span a type b type. Okay, so we actually depend here on the unification of variables. G inference unite, and on the unification of types. Okay. Okay, now we have this. The type T value scope T is not compatible with T into var scope T, but value scope T must be var scope, right? So how do we do that? That's the question now. Type T, so value scope T is not compatible with var scope T. Because we need to say here that this is not just value as. Value as is the signature on where we have this depth var scope T. Wait. No, it's in the dependency of what a value wait. What is? Hold on. Value scope t is not compatible with var scope t. They are the same types. I need to like write this down somewhere that they are the same. If only my error message was better. Type t, value scope t is not compatible with t. Well, hold on. It's value scope t. I need to figure out where this is. Yeah, so var as... Okay, there it is, right? So an inference variable has the module value, which is inferable, but we must say what the value is, right? For the vars, I think, over here, this value var should be like inference var as with... Can I say with module? I'm not sure if I can say with module. Maybe I can. With module value equal to value shape. This module is recursive. This use a recursive module shape within... Yeah, I don't think I can. So we need to say with type value t is value shape.t. Is that the one? Oh, and value scope t is equal to var scope t and type. Is that how you write it? The type t is not equal to the type var scope t. Type declarations don't match. Type t is scope t. Is not included. And t is var scope t. Inferable signature has scope scope t. Yep. Inference var make value shape. Because this is implementation value shape as, which has in the dependencies scope, inference scope, I guess this is too abstract. I need to say that module scope is equal to dependencies value scope, maybe, which means that value must provide the module scope, which is inference scope. Is that correct? Now the signature is mismatching. Module scope. Oh, and this is depth var scope. Wait, hold on. No, we have depth var scope. We don't say that. We say depth var scope. Can I just make this in the signature? Depth.var scope. Value scope t is not compatible with var scope t. Value scope t. Value scope t. Where is this used? It's used over there. Oh, it's also used in the rows. Is that the problem? It's only in the row polymorphic row stuff and in this inference based stuff. Type T, value scope T is not compatible. And this. as in this type, right? Yeah, there you go. Type declarations don't match. Type T scope T, type T var scope T. In module value.scope. Value scope. Okay, yeah. So value over here. I'm defining what a value is. Value signature. It just has the. Well, I mean, value signature does not even specify what a scope is. One second. All right. So what's my problem? Scope T and var scope T somewhere are not equal. It seems like it's not equal over here. So over here, I'm just making the inference var make. Inference var make. Oh, this is where we have the value scope, right? Yeah. We say over here that we have a value. Well, yeah, we have module value. This is my like thing, and this has value scope T, right? In module value scope, the type declarations don't match. T, a scope T is not included in type T. Is var scope T. T is not equal to the type var scope T. So this is because of value shape, right? Value shape is a value shape as. Value shape as contains the scope now. There we go. So this is dependency var scope, which is just an inference scope, which is not necessarily equal, right? So do I just say here that this with type dependency var scope T is equal to var scope T? Is that right? Type declarations don't match. Type T scope T is not included in T is var scope 2T. Scope is depth var scope. I did some googling around. It looks like Idris is lazily evaluated during compile time so that it can handle recursive types, and then strictly evaluated during runtime so it can be called by value. This led to people noticing that code in the wrap will have different semantics than the same compiled code. Yeah, I guess. That's also probably the reason why why I am having performance problems right now in my interpreter, because I mean, so like, yeah, because I only have like, so basically Idris has 2 interpreters while I have a single interpreter. This leads to me having performance issues because of like this lazy, I mean, it's not really like lazy, but yeah. So the interpretation during compile time for compile time evaluation is different, and is slower than what we can do at runtime. Which and because I'm not making the distinction, my runtime is slow currently. If you run the program through the interpreter, yes. But I think I'm not going to have a different interpreter. Instead, I'm just going to transpile to like, or compile transpile, something like that. I'm not sure if I need a second interpreter. I mean, unless with JIT, because JIT is basically a second interpreter, right? Alright, I'm struggling with understanding how to do my OCaml again. How to make the type checker not fail var scope 2t is not equal to scope t. How? Module shape s. We have dependencies. Module scope is def var scope. Well, I mean, there's also scope, right? Can I just say and type scope t is equal to var scope t? I mean, this is the same type though. That's the whole point, right? So I think this should this is like duplicating the same equality already. Type t value scope is not compatible with t var scope. Definition of module var scope is over here. Wait, what? That's not the definition of the var scope. Hello? OCaml? That doesn't look like the definition of the var scope. Oh, or does it? Wait, hold on. The definition of var scope is here. Oh, it's because I have the names here, and names contains the name contains this the optional var. There is no var scope here, not yet at least. No, this error message is just completely bad, right? Or is it not? One of the var scopes comes from the implementation, and one of them is coming from this. Weird. Value shape as depth. Let's see what else do we have here. Compiler scope, interpreter scope, var scope. Var scope. We just have the type. Oh, column. How to understand this error message? Or maybe this error message is pointing here, but the error actually is in another place, because we have like multiple errors here, right? So maybe we should look in the other one. Value t is value shape t, and value scope t is var scope t. These are the only types that are present in the inferable, right? Value inferable just t and then scope t. Yes. So we just override these two types, and then value is this, and that says that type t var scope t and value scope t is not compatible. In cast types impl value t deps value var. So we have a value dependencies over here. The value dependencies contains the var, contains what's the error again? Value var, not var scope, but value var. Yes, yes, yes. And value var is this. I have said that the type here is that. Oh, I see. But the types here are still the old ones. Yes, 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 yes. Can I wait? Can I even can I even do that? So like this type here must also be duplicated to value shape over here. Value shape. Value shape is this type, right? Value var is this type. Can I do this without copy pasta? Like, I'm not sure. These are the only two places for now that I'm doing, right? Hit module value var. Did this not fix it? This is my all things. Value shape, value var. Or do I also need to have the value? Value s. Value s has scope, depth var scope t. Right. So this should be that with type depth var scope t is equal to var scope t. And now it's like probably the type or whatever. No, the error is still the same. Well, we see over here that module var scope is sig, where type t is all.varscope.t. Right? Wait, but scope. The scope is a function that that figures out the type. Value var. Value var. Value var. Value map. Value var is this thing. Value var, inference var as, with value t being that, and value scope being that. Yes. That's the only thing that I have to do. This should work. How to decipher this error message? Type t into value scope t is not compatible. The declaration expected is over here, by the way. I can go there. So this is the dependency of a value. This is var scope t, right? That's what we want to have, var scope t. And this is not compatible. So what we are giving it, the actual declaration is here. This is value scope t. Right. But isn't value scope t set to be equal to var scope t here? I don't understand. Because value scope t is equal to var scope t, but var scope t or is, oh wait, hold on. Value var scope t is equal to var scope t, right? Well, here's the dependencies of the value. We have var scope. What am I working on? Hello, Jenny Cloud. I'm trying to refactor my programming language, so I'm working on my programming language. I'm trying to make it work because like in order to make progress, I need to do things which require refactoring. I'm writing OCaml. Refactoring requires using the recursive modules, and it's very difficult to do in OCaml. So I'm trying to decipher these error messages, what they mean. Why does it not type check? That's the question here. But yeah, we have the language which is very recursive in nature. So we can have values which contain types, types contain values. Everything depends on each other. Like I mean, I should be able to figure this out. If not, though, the alternatives are... I don't even know what the alternatives are. I can, like, maybe try to come up with a different solution to my problem. I'm not sure what that solution would be, though. Okay, here's my error, right? In this file, these modules do not match. Line 103. 103. So that's when I'm creating the value. Okay. Well, one thing that I can try to do is I can specify the dependencies explicitly. There's only 3 of them. Var scope, value var, and type. So instead of having all here, we can try doing this struct. And like module var scope is var scope. Module type is type. And module value var is value var. But the issue is going to... Okay, it just makes the error message a little shorter. Okay. Wait. Does this make the value... Okay. We have a different error now, that the module type is not providing the value scope, which is correct. That is understandable. But how is that different from that? Because the signatures are different over here, right? Over here, I'm not specifying the signature of this type, but over here I am. Okay. So I can make my dependencies be explicit like this. But I actually have to figure out why is the signature different. Alright, well, anyway, let's move on to this other error then. Scope is required by not provided, right? So my types must be unifiable, right? So we need to have a value scope, which t into var scope t, and we have unite, which is t inference unite. I'm going to say that my dependency has var scope, right? Type var must have the value scope, which is t into var scope t. Type var must have unite, which is t inference unite. So we have a scope var is deps type var scope var, right? And unite span ab is var is deps type var unite span a var b var. Okay. Do you know how hard making a very basic LLVM backend would be? I'm tempted to try. LLVM backend for what? Oh, an LLVM backend, not the front end, right? I see. Yeah, I don't know. I don't know. Why do you need LLVM specifically? For the Cinecore VM? Yeah, but aren't you writing it in Bash? Wait, are you saying that you have the that you're using LLVM as your backend in Bash? Are you compiling Bash to LLVM? Or are you saying that you want to come? Wait, hold on. Are you going to make Bash as a backend? It would mean to try write a program targeting Cinecore VM. You already finished? Yeah. I don't know. You can also try something easier than LLVM, I think. Because like you just need to figure out where QBE is used. This is a backend, which is like a lot simpler, as far as I understand. So maybe you can quick comparison with LVM. I don't know. I never tried these things myself, but yeah, I'm just saying that maybe you should try a simpler alternative to LLVM. But maybe LLVM is not that difficult. I just never tried it, so I don't really know. Is C a nice backend? Well, C would be front end in that case, right? Batchcop wants to compile a program for the Cinecore VM. So, like, if you can compile the C program to the Cinecore VM directly, then, right? Because C probably has a QBE as backend in one of the compilers, and then you would be able to do that. Here's another alternative, by the way. You can try like you can QB is more than you want. What about WASM? Like you can compile like a lot of languages to the WebAssembly, and then you just write the WebAssembly to Cinecore thing. See, because WebAssembly is pretty simple, right? I think. Okay, what are we doing here? So yeah, types can be done now. Modules don't match. Var scope and value scope T. This is the same issue as with my values, I guess. Can I just say here module, or I guess struct end? So I'm just going to pass the dependencies explicitly then. So the type dependency is just var scope and type var. Var scope is var scope. Type var is type var. Oh, and type var. I never introduced it here. And type var. Inference var as is inference var make type shape. Right? Oh, wait, no, wait. I have type var over here for some reason. WASM has a lot of instructions. You can probably ignore some of that. Like, some of them are new, right? Like, they introduced the garbage collector in WASM recently, WASM spec. You can probably ignore that. Do they actually have a lot? Index of instructions. Wait, is this the full, all the page of the of all of the instructions? Oh wait, that's a lot. What's the line number here? Wait, throw? You can actually do the throwing? That was not possible before. That's the new stuff with the garbage collector, probably. The throw definitely was not possible to do in WASM directly previously, I think. I'm not sure though. Well, binary of code is 0x8, so probably it was. But yeah, this is reference types, which was only introduced recently, no? I thought. Maybe, I don't know, I never looked at the specification. Modules do not match. A value scope T is not included in var scope 2T. Var scope, inference scope. Value scope T is because type var should be inference var as with type value T equal type shape T and type value scope T equal to var scope T. Is that what I want? Signature mismatch now in module value scope. The type declaration don't match. Type T scope T is not included in this because T is not equal to var scope T. Type shape, because type shape is impl type shape as with type we have dependency which is var scope with type dependency var scope T is equal to var scope T. Type shape, give this a struct with dependencies. That's a lot of dependencies here though. Like that. Modules do not match. Module type. Type. And type should be impl type as with type var scope type depths var scope T is equal to var scope T. You do QBE and then you have to do the rest manually. I don't know, isn't there documentation how to add another backend to QBE? Depths var scope T is not compatible with var scope T in the name. and the name. And module depth var scope. Expect declaration. Actual declaration. Value shape. Oh, it's because we still have used this all thing. Maybe I should just not use the all thing, and because this does not work. Apparently. So I just give the dependencies like that manually instead of having all. Let's just comment out all together. So instead of doing all, I'm just going to pass the dependencies explicitly. What are my dependencies? In this case, right? I guess I just do struct end instead of all. Oh my god, that's a lot of places. Struct end where I need to do copy paste now. So this needs value, blocked value, and binding, right? Module value is value. Module binding is binding. Module blocked value is blocked value. Okay. Modules don't meshed. Module blocked val. Wait. Yeah, there you go. The error is gone from here. Now here, this needs just module type for blocked value. Module type is type. Module blocked value shape. Module blocked value shape is blocked value shape. This is some var scope 33. Oh, we have 33 different var scopes, is that right? So this does not work because this signature... somewhere is not overriding the thing or something. I'm not sure. I need to like find the actual place where other language, like whether other projects are using that. The OCaml compiler uses recursive modules with functors all over the place, especially in typing, lambda, middle, end. OCaml source code. Typing. Dependencies between modules. Most of the modules presented above are interdependent. Since OCaml does not permit circular dependencies between files, the implementation uses forward declarations implemented with references to functions that are filled later on. An example can be seen in type core type module, which is filled in type mod. Forward declaration to be filled. References to functions that are filled later on. This is a reference to a function. Oh yeah, and yeah, okay, so this is the blanket implementation. The function just asserts false, so it's like panics if you try to call it without it being filled later. That makes sense, yeah. Yeah, we do that also in some places. But this can not work for defining the types, right? Which is what I'm trying to do right now. Like, how do you create the types that are recursive? This is recursion between the functions, right? I don't see the actual module rack. Can I do quotes here? And just some manuals. That's a test suite. This is all test suite. This is all test suite. Wait, they don't actually use the recursive modules. They use the forward declarations of functions. But how do you forward declare a type? That's the question. That doesn't work. Recursive signatures. It would be useful to have support for recursive signatures. The most common need is code involving first-class modules, where I would like to write module type rec, this is that. Of course, there is a workaround, but it's rather clunky. Module rec r sig, module type t is sig, val f, module rt into unit. Yeah. Now that we have both recursive and non-recursive type bindings, it will be more uniform to support both recursive and non-recursive type module type bindings. Okay. I don't know if this would help me, but maybe. But it's not implemented. Recursive modules don't correctly handle variants. A tiny bug in type checking recursive modules. What if I have a, what if I'm hitting a bug? A tiny bug in type checking recursive modules. Module rec am sig type t is ns is a. Type t is ns in is a. And n is this. Type checker reports the variant or record definition does not match ns, even though it's explicitly saying that it's ns. Is that the bug that I'm hitting? Bug with recursive modules? Let's try to make the simplified example of what I'm trying to do in the OCaml playground. So like over here, right, we are creating the two types, right? I need to unify the types, right? So let's say that we have another thing which has module type depths. So like we have a dependency module scope sig type t, and we say over here that we have, let's remove print and unite. We don't need that right now. Just simplify this thing a little bit, you know, simplify this thing a bit. But instead we have the module scope as a dependency of both a and b. And then we have in the signature value scope, which is t into scope t, right? And over here we say, yeah, and we also say here val scope t into scope t. This says let scope is function empty. Then well, I mean, let's just fail with b then depths b scope of b, right? There you go, something like that. And in this case a has the val scope t scope here, let scope is function empty, fail with this. Stop, don't open this. A then depths a scope a. Signature mismatch. Values don't match. Val scope t into depths to scope t is not included in scope ta. The type t depths to scope t is not compatible with ta. Type depth scope t is not compatible with type a. Definition of module depths. Definition of module depths 2. Expected actual. Oh yeah. We need to have like we need to have like scope, right? Let's have it in the impulse scope as impulse scope t module scope module type s sig type t module t s struct type t. Let's say unit here. It doesn't matter. And let's say over here module scope impl scope s module scope is scope. Unbound module scope. Oh yeah, this should be like depth scope t. Of course. There we go. Yeah, so now this says that depth scope t and t scope t, right? Depth scope t is not compatible with scope t, right? So because of that, what we need to say is that impl as is actually impl as with type depth scope t is equal to scope t, right? Impl bs should also be impl bs with type depth scope t is equal to scope t, right? And yes, we still have this error. I guess I can even try, so like this doesn't even require the recursiveness here, right? I don't need a and b. I don't need a and b. Bug, OCaml bug. I want to check this. I'm going to revert that stuff. Unbound module June. Okay, this is bound. All right, let's see here. So I'm just going to have the only thing, which is B. So we have a dependency scope T. Module S is dependencies. T is just say unit here, right? Or I mean, yeah. And over here we'll say something like val root unit into T. Why not? That's what my scope is. Okay. As depth is depth, type T is unit. I don't even care about this type here. This can be abstract. So then scope. This is depth scope root. Then we remove the B. We say type S is this val root unit into T. Lat root is this. Okay. So now we just say that module scope impl scope S is impl scope T. This probably doesn't even have to be recursive, does it? Because that's the same thing. We just say module A impl A S is impl A make struct module scope is scope. Does that work? Seems like this works though. Seems like this works. This works. So like I do need okay, so the problem is with recursiveness. If I what if I say module rec and this is that? Seems like this still works. I wonder if something like this would be even better. A small C compiler. Wait, why don't you just use this tiny C compiler? Tiny C compiler, right? Tiny CC. This is literally tiny. Just change the backend here. You probably can generate a new backend here easily. Well, tiny C is like the famous one. I have never heard about the chibi CC. A small, so like this one is small. The other one is tiny. You know, tiny is usually smaller than small, right? They don't reference the tiny C compiler. Does this one reference the chibi? No. Okay, so I have to have two things here. From the README, you can do TCC run. Yeah, it's the interpreter too, right? I think. I'm not sure. Is it interpreter or is it just like compiling it immediately? I don't remember. Value root is required but not provided. Impulse scope as so yeah, there should be like val root unit t let root. There you go. Okay, so we have this error, right? T is not equal to scope 5t. Is that so? That's the same issue. Let's try to like make this even smaller. This is still like 100 lines of code. How do I make this smaller, right? I can say that my dependencies are just... Wait, why is there a B? B is not in the dependencies, right? Wait, no, this doesn't work. Unbound module depths B. Never mind. The error does not have B, right? Module B type T val scope T scope T, right? Yeah, there you go. So the only issue is here, which is still the same one. Type scope 2T is not compatible with type scope T. So what's the problem? Let's try minimizing this. Let's not use inner modules, maybe. Let's not use inner modules. Let's just say over here that we have type B. And we have type scope. And we have val root scope, which is unit into scope. And we have val scope of B is B into scope, right? Just do it like this. So instead of depth, so this is going to be like depth scope B, and this is going to be depth root scope. So this one is going to be type A. Scope of A is this. This is depth A. This is depth B. Depth A. This type can be abstract, sure. Scope, depth, root scope, depth, scope A. Depth, scope. With type, scope is scope T. Scope is scope T. Scope is scope T. The signature constraint has no component named scope. Impl AS. What? AS? Oh, type depth.scope, right? Like this, okay. Seems like the error is now type scope is recorded but not provided. Yeah. So all is the signature, which where we have we will have type A, type B, val type scope, val root scope, unit scope, scope A scope, scope B scope. Hello, that's Razor. So this is just going to be type A is AT, type B is BT, type scope is scope T, let root scope is scope root, scope A is A scope, scope B is B scope. A depth scope is not compatible with type scope. That is the same issue, right? Maybe I don't even need to specify these things, actually. How about that? I don't even need to specify the functions at all, right? Let's not specify the functions, like, at all. I just declare what the types are. Because I need those to type check. Unless, I mean, maybe like this type is different. Type scope is not equal to scope T. Oh, is it like over here and say like type scope is equal to scope T? No, it is equal here. Type A is AT, type B is BT. I don't think we can do that though. I'm not sure, maybe we can. Type scope is not equal to the type scope T. The definition of module scope is the actual definition is here. Depths. Okay. This is 67 lines of code. Can I minimize this further? Can I get rid of type B altogether still? And not have it as my dependency. We just do that. No B, no B, no B. Right? This still has the same issue, saying scope is not equal to scope. Okay. Can I make it even easier. Let's get rid of this all, right? Is it because it's inside of the inner module of the thing instead of the type? Oh, maybe that's the case. Maybe that is the case. Let's try commenting everything and say something like this. Module rec A has signature, which has like module inner, which has signature type T, right? Which is equal to struct module inner is inner. I feel like I want to look at TCC repo from 5 years ago instead of main. And inner sig type T and is struct type T is unit and so this works, right? But let's say that this over here is let's say over here module type a signature is sig that, so this has type as. I want to say here as with type inner dot t is equal to inner t. Let's call this daps t. Daps type inner. Daps inner is inner t. Because this is daps, right? Like I still what's the difference? Module impl struct module A. Is it because it's a functor or whatever? Oh wait, it is. Yes, I understand the problem. Hold on. I think. Right, the problem is that a make is returning as signature. If I remove this signature, then as you can see this compiles because this signature makes this abstract. So but this should be like this should basically be as where can I say something like with module daps as equal to daps? Can I do that? And then it works. Oh, look at this. This works. First released 24 years ago. The first version is literally insane. First implementation of Tiny C compiler. How do you look at it? Is it like five lines of code? And this is the mirror. But it's 900 lines of just raw nonsense. Oh, initial TCC, let's see. Text size 20,000, data size. I mean, that's not really nonsense, I think. Some limits on the sizes, right? Some nice variable names, talk, vac, vat, lsim, rsim. I mean, that's pretty self-documenting. Oh, I mean, there's documentation here. Don't worry about it. Right. What's the nonsense here, though? It's readable except when it does output. Or is the output happening? Isn't next this is just doing the parsing, or is it doing the outputting while parsing? Void OC, while C, G, C, C is C divided by 256. What? GC, int plus plus is C, int plus index plus plus, as char star is C, right? So this is like literally putting the character into like the output. Index is like the output code pointer, yes. So G is just putting the character in the output. That's what it is. And output C, so like this is like a potentially multi-byte instruction, I'm assuming, right? So it puts all the bytes into the output, that's all. No? Maybe? I don't know how this works. Instruction plus 4 bytes data. Wait, can you do this in C? Declare a function and without declaring the type of the argument? Or is C defaulting? 1 second. All right. C defaults to int. Yeah. Okay, hold on. So we need to do this. And then we do that. But can I say over here with module depths is equal to all? No, because this makes this module type recursive and we don't want that, right? Of course. Which is why we are doing this. Which makes it very annoying. Okay, so my solution to my problem is going into all of these places and say that as with module depths is depths. I need to add this to everywhere, right? To every make that I am doing here and there and everywhere. So can I still have the all thing though? And have the all after all makes? Can I? All struct ends must be all. Type T is not equal to var scope T. In module type var. Yes, so type var is this type over here. In module type var. No, I don't know. This is cursed. Type T depths. Type var. Type T depths. With depths. Oh yes, because module type is this, right? Oh, okay, over here. This is the incorrect one. In module type, with type depths, our scope is var scope t. What is the syntax error? There is no syntax error. This literally looks the same as this one. Hello, Stu squared. This does have var scope. Syntax error. Can someone explain to me how this is a syntax error if this over here is not a syntax error? Let's move these things closer together and see the differences. So if I replace all values with types, then it's literally okay. I see the issue. Okay, dot t. Fine, it is a syntax error. It was a syntax error indeed. Okay, it looks like my my OCaml language server is also lagging when I'm trying to do this. I'm thinking about doing something silly, please talk me out of it. Have you already solved all the other like advent of codes that there are? Maybe you can do something like that instead of writing the compiler to the scenic core. Value scope T is not compatible. In module type var. Let's take a look. If can I okay, hold on. We just do build into the error. Module type. Okay. So my signature is like this. We have module type where type T. This is blocked value, right? Okay. In module type. This one in module type. Module var scope sig type T is type var value scope T. Oh, there we go. This is incorrect, right? Well, I mean type var value scope T should be equal. Var scope T is equal to that. But this also should be equal to my var scope T, right? But we can kind of see the issue here because we have type var. This returns var scope T, which is that. Meanwhile, I want to put it on the browser. What do you want to put? The Cine core? A virtual machine or something? We are sidetracked. Yeah. Am I familiar with it? I did not do the Cine core. I mean, I looked briefly that you just need to implement the virtual machine there for like the imaginary virtual machine, right? To solve the challenge. That's all that I know about it, basically. I did not solve it yet. I solved the advent of code. I solved the yeah. But I think I will try the Cine core at some point. But I want to fix my language, and I'm really stuck right now. And I don't know how to fix my language. Because this is a pain in OCaml, what I'm trying to do here. Well, you will just have to inject the module of math instructions. I don't know if I can do it. Do you guys hear my neighbors drilling, by the way? I'm trying to think here, and then the neighbors are drilling. It makes it double pain. Currently coding up the VM for the Cine core. It's kind of broken at the moment. We'll figure the pebcak. I don't know what pebcak is. You cannot hear them? I mean, I can make it so that you can hear them if you want. Hold on. Let's remove the noise suppression. Can you hear them now? I think you can, right? I think this chibi CC one will be easier to fork than tiny CC. Tiny CC is quite large. Okay. I might want to give up on this. On this thing. But if I give up on this, then I need to have a different solution. Let's giving up. This is in a different branch. Let's go back to the main branch then and see what I was trying to do. Right? What was I trying to do? I just need to like add the thing. Into my types. So I have the inference, and for every inference variable, I want to know the scope. And I want to replace this subbed in with a different thing. Because right now we have a huge performance problem. Because I'm doing too much substitutions or whatever. We fix that by having the scope information for every inference variable. In which scope is the variable defined? So which variables can it potentially be equal to? This means that I need to move this to the place where we know what the scope is. Or make this generic. So we have a variable which has scope. I already tried that before, right? If we have two things, a and scope var. So this is going to be a and scope var state, a scope var state, closer to root a scope var, a scope var data. A and scope var data. I mean, technically for every type, I only have I should have a function from type to scope, so that yeah, but that's impossible to do in OCaml at all, right? Unless we use the functors, which is what I was trying to do, and it broke, and it's too difficult. So we just keep the two variables. So when we say new not inferred, we have a and scope. We return a and scope var. So the variable data should contain not the subbed in, it should contain the scope of type scope. When I create a new not inferred one, I must give it the scope too. So I just say that we have the scope. When we create a new inferred value, this means that we need to be able to retrieve the scope from a value. So we need to have a function. We need to have a function a into scope. And then we can construct the variable. Right? So inferred scope. So in this case, we say that scope is inferred scope of inferred. Find root variable. A scope. If we have a scope var into a scope var. I mean, for a lot of things, the scope is the same type. So for a lot of the things, the scope is the same type. So what we do instead, let's actually move this back. So instead what we do, to simplify this a little bit, we're just going to move this type I'm just going to move this type into the place where we define all the types, which is over here. So we just do this. We declare these types over here. And we need to copy paste like so. But now the deriving strikes. Can I implement a custom? Okay, hold on. Now the problem is the deriving. Can I in OCaml implement deriver that only derives functions for some types from recursive group, not all of them? Yes, but it's annoying, fragile, and you'll hate it, just like everything in OCaml, right? Hello, Betseg.
Hello, Betseg.
What a great idea. Happy to help. You think that's what my ChatGPT would tell me? No. What the PPX actually sees. We have two types. This is a recursive group containing multiple type declarations. The group is atomic for typing, but not for code gen. The deriver can inspect each type declaration, decide to generate code for some and not others, emit any structure items it wants. Yes, the real constraint. If the generated functions refer to each other, you must still generate bindings that make recursion valid. So you have three cases. Derived functions are independent. Fully supported. That's not working though. This is false. This is ChatGPT lying to me. I just realized what this means. If I succeed, I will have a C into Bash compiler. Nice. So the problem is that all of these types are recursive. Well, I mean, okay, maybe this is not recursive, right? That's what we're talking about. But the scope is recursive. If I use the scope, if I'm okay, so like the generic parameter adds the indirection, which means that this does not need to be recursive. But if I use the scope, which I actually plan to use, without that indirection, then I need to move this into the recursive group. The scope that I want to use is like the interpreter scope, this one, which contains all of the other things, which like all of this is recursive. Oh, annoying. So maybe like the original way that I was going for is the way after all, where I don't move this here, but I make my variables work with the scopes. But can I have this still have a single type argument though? That's the question. I don't think I can, right? No, I cannot. That would require making that a functor. Can you send a link to a particular image? Sure. I mean, yeah, I understand the I understand the image you're referring to. It's rewrite time. Yeah, but yeah. Rewrite is one way to solve this, right? But what do we rewrite into, and so that we don't have the same issue, right? So once the issue is the same as what we had in Rust, basically, but in Rust this leads to bad compilation times. In OCaml it leads to like just like it's just annoying. I guess very super explicit with copy pasta everywhere 5 times or something. That's hot. That's hot. So how do we basically have something that allows me to structure code like in Rust, but without having the compilation time explosion? That's the question. And without Scala? I was previously thinking about F#, but I think F# will have the same issue as OCaml currently, even although maybe F#'s tooling would be better. I never tried Scala. We could rewrite in Scala. How long do you think my rewrite is going to take? How long is this rewrite? Haskell? No, Haskell is bad for compilation times. We want to not have horrible compilation times, right? Compilation times are quite bad in Scala too. What's a programming language which is I mean, Go? Do we want to try Go? I'm going to hate my life so much. It depends, but I think he's talking about compilation time, runtime forecasting the language. No, I'm like the compile time of the cast itself. No, so yeah, the compilation times. Python basically has no compiling time. Python would be possible indeed, right? Python, TypeScript, Go, something like that. So I guess like out of those, I would choose TypeScript, I guess. Maybe. JavaScript. Well, yeah, we don't want to do purely untyped stuff, right? We want to have some way of catching bugs. At least some. TypeScript is the sanest. Do it in Bash, then Batcop will help me. What if just Batcop does it for me? Batcop, can you like just make my programming language work without me struggling with the programming language that I use? Just to be clear, you're trying to optimize the compile time of the project or the speed of the compiler. The compile time of the project, yes. Well, I mean, I'm not trying to optimize it. I'm just trying to make it good enough. So when I was working in Rust, right? Rust is a language which, like in theory, makes my compiler fast, right? But the compiler was compiling slowly. That's why we no longer write Rust. That's why we write OCaml now. The runtime is not very important, I guess. So I'm not sure if like if the runtime of Python is quick enough for me, but I mean, probably. I don't need it to be super quick. I just need to be quick enough. I just need to be able to like structure my code properly without struggling with the language, which OCaml is a very difficult language to write. The program that I'm writing, like if you write something simple in OCaml, like trying to solve the advent of code, for example, then OCaml is very nice and clean language, I guess. So we want what we want is to create a highly recursive program, right? The recursion is the issue. So in Rust, if you try to like have a lot of recursive types and all of that, this means that you have a single huge crate, which is really bad for compilation times. In OCaml, recursive types require recursive functors, which absolutely break the language and make it impossible to deal with. If it's like a little bit of the local recursion of the functors, I guess it's okay, but if like basically the entire language is recursive, then that's, I don't know. So this over here, this file that we're in right now, this is 1500 lines of code, which just declare the types that I'm working in my programming language, and everything is recursive here. Bum, 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 bum. I think I'm open to rewriting, but like how long do you think, I don't know. How long do you think would it be? Compile times aren't great in Scala if you're using fancy types and derivation, but it does have great incremental compilation. Yeah. Maybe we should just go TypeScript. It's inspired by OCaml, so you might like some similarities. I'm not sure if inspired by OCaml is an upside. Boom, 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 boom. So the amount of code that we have right now is just 16,000 lines of code. How quickly do we write code? Let's say that we write 1,000 lines every day. This would take 2 weeks, right? Let's go to the previous version. This over here. This is the old Rust version of the language before we started rewriting into OCaml. Basically the same amount of code, right? So we are basically at the same, we're almost at the same state. We're actually at the better state right now than our old Rust version. The Rust version had less features at this point, I think, even than my current version. And like, we didn't even have the LSP here. So we have more features in less code, actually, which is surprising. I feel like maybe there is something that I'm not counting here. Ask ChatGPT to translate to TypeScript. I'm considering Go, actually. Like, isn't Go good? Should I do TypeScript or Go? TypeScript or Go? Neither. This is a false choice and it's wasting your time. Great for shipping fast, terrible for sleeping well. I think TypeScript makes more sense. Do we do this, or do we like, I don't know. I feel like I should try a little bit more before giving up and starting the rewrite. I need language that's easy to write and fast to compile. Compile time scales horribly with project size. What about Haskell? All right, let's try for now. Like I'm just literally making no progress, which or TypeScript has recursive imports. What are your current compile times and lines of code? In OCaml, the compile time is very fast. I don't even notice it. OCaml is really fast to compile. I don't have problem with that. So like maybe like even though Scala is slow to compile, it is still a lot faster to compile than Rust, for example, right? My compile times though, the reason I'm not writing Rust anymore, Rust was 17,000 lines of code. OCaml is right now also around the same 16,000 lines of code is what we have. Right? So, you know, OCaml, if I do it from scratch right now, let's remove this, right? So we do done clean and done build from the beginning. So, I mean, this is not instant, right? And we not always build from scratch, but still, this just took 11 seconds, right? To compile. In Rust, and this is from scratch, right? The incremental ones are faster, like a second or something usually. So in Rust, for the small incremental changes, I was having 1 minute of the compilation time, which is really slow, right? From what I heard, Scala sounds like it's even slower to compile than Rust. Okay. Yeah, I guess like the only... Okay, so the only language that we are considering then as rewriting into is TypeScript, right? I guess. They are rewriting the TypeScript compiler into Golang, which is a bit interesting. Well, I mean, but the reason for that is because they want to make the... well, I mean, yeah, I mean, I would rewrite it into Rust if I cared about like the compilation, about the runtime, right? the same time, bum, 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 bum. All right, I'm not going to start the rewrite today anyway, so let me try to solve my problem in the in a different way, I guess. So instead of doing this refactoring, we are trying to just do this, add scope info to inference variables, right? So we're just doing the same as I started and then I stopped for no reason, right? We just have a and scope. So variables, they have scope associated with them, and we are breaking the dependency cycle by having scope as the argument to this type, basically. That's how we break the dependency. Right? Right. Yes. Data, mutable, scope, new not inferred, requires scope, a scope var, a scope, span scope, scope. So yeah, it also means that unite. Never mind. New inferred. This requires to have like a into scope function, right? Inferred scope. Scope is inferred. Scope inferred. There's another option. I can use like obj.t and do unsafe coding in OCaml, I guess. Find root var a scope a. Can I just do underscore here and it's like Rust incremental compilation is at the crate dependency level. Scala's internal compilation is at the symbol level, so it's very fast for small edits, even if the clean compile is slow. I've been fine with it in 50,000 line of code repos. Yeah. So should we consider Scala? Okay, so we will start the rewrite into Scala, and then after like a month or 2 months we will see the problem with Scala, and then we will start rewrite in TypeScript. I'm so close to being able to self-host though. I just need to fix a couple more issues. Consider cast. I am considering it, but it's not ready yet. Scala self-hosts. We can see how long it compiles. It takes to compile Scala itself. Let's take a look. Scala source. Scala lang. Do they have a flake? No, they're using the Docker. No. Oh, Scala 3 is a separate repo from the Scala lang. I mean, we can take a look at their GitHub Actions probably, right? Because isn't this 18 minutes? Compile full standard library. All workflows. Build Scala launchers. Build Dotty Copilot. Dotty Scala 3 with capture checking. Specification. Right, like what is this? That took 18 minutes here. This is just building, right? Set up JDK 7. Compile and test. Well, I mean, there's also tests, of course, right? So, maybe the tests take a long time. Does this thing says how long the tests run? Done compiling. This doesn't have like timestamps associated with the lines, right, in the logs. Generate self-documentation takes 60 seconds. Isn't that a long time? Like after we have compiled the project already, the generating documentation takes a minute. Dotty is the compiler. Yeah, 30 minutes, 12 minutes, 13 minutes, 30 minutes. I guess depends on if something is in the cache or not. I don't know. Maybe. Why is this 30 minutes? Bug fix. Oh, because there's a bunch of things, right? Test Windows, yeah, because they are testing on Windows, and Windows is just 3 times slower on the GitHub than Linux or something. So it's like 12 minutes. Poll 1, we do the rewrite. Hold on, how many people did vote? Just 2. All of those are going to be clean from scratch, so you wouldn't expect anything small. Don't they do... I mean, it depends. Like, it depends if they do the caching on the CI, because you can do caching, right? Is there a cache? Cache? There is a cache, right? So, it depends if they only cache the Java binaries or the like target folder basically in Java, right? Because I think that is something that should be happening here. Cache size 240 megabytes. Will you write the self-host target transpiler in cast or in OCaml? A built-in? Probably a built-in. Because writing it in cast itself requires exposing the API to inspect the compiled code to write the compiler, right? Which I'm not doing yet. Or OCaml. Yeah, but the transpiler is kind of like self-contained, so that doesn't really have the problem that I'm having right now. All right, let's try this. We have scope A and scope B. So this means that in order to unify two variables, we now need to unite. We need to unite scope, right? Yeah. So we say that unite. So that we say the scope is unite scope. Scope A and scope B. Can unification of the scopes fail? Should this also take the span as the argument? Probably not, like at least like for the way I'm going to use it. So this cannot fail, unlike the unification of the variables. I remember subbed. A scope. Remember subbed is something that we don't need anymore. Was subbed in is something that I don't need anymore. What I want though is I want to find this scope. The scope is if we have A and scope, if we have a variable, then we can get the scope out of it, right? Yeah. So this is a function variable into root is get find root var in root scope, right? That's all. Unite. Yeah, so this should be like a unite into, I mean, sure, let's say scope unite. Why not? So we have a unite, we have scope unite, then we know how to unite the variables. Sure. Unite inferred, unite scope. So unite data, unite inferred, unite scope. A scope. Unite data, unite scope. So unite scope is after all going to take the span as the argument then. Unite data, unite scope. Over here. All right. Infer as this also must have unite and scope unite, and then we have a scope var like this. So we unite inferred, unite scope, unite scope. The definition has type B, C, D, unite. Oh, because okay, new inferred must be scope. Okay, well, infer as. So the scope. Yeah, this also needs to have a function which takes the scope up to the inferred, right? So we need a into scope function, right? Inferred scope is another thing because new inferred requires that. Okay, there you go. Once inferred, we just take a unit into a scope var, effect type a scope var, a scope error shape a scope var. And then we say type a var equal var type a scope var is a scope var t. I don't know if that's needed, but okay, sure. So this specific one works. Now we know, so now we have the inference variables of labels. So like labels can be inferred, right? The scopes for this is going to be the no scopes, I guess, because this cannot contain the variables. And this is like in its own module. Yeah, this one is instructed. So let's just say inference no. Let's say no scope t. I'm going to have this here directly. Module no scope. Type t is just unit. Module let root is this, and unite span this is this. That's all. Let's have the signature here so we don't expose the functionality. Probably val root unit t val unite is t inference unite, right? There we go. Okay, so we have label data no scope t. Create definition. We create the new inferred. This requires the a label is label data. So we are inferring the label data, right? So this should have label data scope, right? And we have something like label data scope. This is label data into no scope t. Its function we just returns no scope root, I suppose. New inferred span here is a named argument like that. Okay, new inferred label data scope. And then over here unification. This requires unite data and unite the scope. So this is no scope unite. Okay, this over here is done. Maybe this is the way. Until I am becoming blocked by something else. Okay, so now this is the row types. So we have rows. And rows, this also should be like generic over the scopes, I guess. So value is A. Or maybe not. Wait, do I need to? I mean, yeah, I do need scope here. Or do I not need? Maybe I don't need. Let's take a look. So we have an inference variable of a shape. But what's the scope here? That's the question, right? Because this is a variable, I must give it the scope. Yeah, I guess I have to. Scope, a scope, a scope, a scope. So this is going to be a shape and scope variable. This is going to be a scope row. The type constructor shape expect 2 arguments, right? So this is going to be a scope shape and then scope, right? Scope with the quote. The value polyscope has type scope bool, but an expression. Wait, what is the value polyscope? What is polyscope? The value polyscope has type scope bool, but an expression was expected of type Inference var a scope shape b. Yes. What is a here? This is a scope shape. Yes. Wait, what's the problem? Hello? I don't get it. Here. There is no polyscopes here. What does that even mean? One of those OCaml errors that look like abstract art, but is actually pointing at one very specific mistakes. OCaml is telling you inference var expects a value, and I am giving it polytype. Polytype is a function. What? But the record field var expects something of this type. What? So somewhere a function is... Wait, does it mean that the error is because of the other code? No, right? Like, we still have the error. Like, this is all of my code here. This is full source of this file. Oh, it's because of the deriving? Oh, wait, so the deriver auto-generates equality incorrectly, am I right? Inference var is abstract, and so its comparison requires scope comparison function. And somewhere inside the var there's something like this. Polyscope. Okay, so polyscope is... Wait, what? Polyscope? Wait, so polyscope is what? Shouldn't this be like equal scope? Because I'm deriving equal, and yeah, so the problem is from these derivers, right? Yes, this is okay. The derivers strike again. Why is that? Because inference var. Because now I have. So because I'm over here, I'm implementing the equal, right? I'm implementing equal over here as this thing, but we also need to implement to have like equal scope, I guess. But equal scope is something that I'm just going to ignore. So equal scope is of type scope, I guess, right? Maybe if I do this. Now we have labels. And label is... Wait, what? Okay, so now we are back to the labels. Equal label AB is equal var. So like, yeah, this equal should be giving us, because we're comparing variables here, we need to give it the way to compare the scope. So right, no scope, in this case dot equal, and in this case dot compare, right? That makes sense. To have equal tt bool, and we have compare tt int. So equal this and that is true, and compare this and this is 0. For the no scopes, that's the easy one. Compare var, compare label data, compare a, compare var compare. Yeah, I did it only for the equal, but we only need it also need for compare. So this is going to be compare scope, right? Fine, let's give it the full type, right? So this is going to be a scope. So first we give it the comparison of A's, and then we give it the comparison of scopes, and then we give it a and scope var into a and scope var into int, right? And this is this function. So this is going to be just ignored. And let's do the same for the equality. Equality just returns instead of int boolean. Okay, so now the row is working. I probably want to uncomment this though. And fix the other places. So now in order to create a new not inferred row, because this requires the new not inferred. New not inferred for the variables require the scope, right? So we give it a span, and we also need to give it the scope. So this takes the scope as the argument, right? The new inferred, though, requires the inferred scope argument. So inferred scope. But inferred scope is basically the shape scope. So we need to create a function called shape scope. Okay, so there's going to be a function if we have empty. Okay, but now we need to like be able to construct the root scopes. Oh my god. Can I wait, I'm actually wondering, can we have the scope as like a first class module here then? Like, can I have over here module type scope is struct is sig type t. So for scopes we need root, which is unit into t, and we need unite, which is t unite. That's all that I need for the scopes, right? So instead of having like inferred, well, I mean, there's also the the inferred scope is different though. Yeah, the inferred scope is different. Are you doing recursion? I mean, I guess not. I mean, yeah. I mean, I'm having recursion between my types. Is the thing that I'm trying to do in making a programming language, and having struggling with like structuring my code. So like I think instead of unite scope, I mean, yeah, whatever. Let's just do that. Maybe. Label. So this should like this signature. Oh, and I also need to like equal and compare them. Yeah, sure. Let's just say that this signature is inference scope, right? So we also have equal t bool, and we have compare, which is t int. So in order to create the new inferred one, I need to shape scope. So shape scope is a function. Let's see here. So we need to have like, if we are empty, then I need to create the root. But this depends on my scope, right? So which means that this should take as an argument the module scope of type inference scope, right? So should this be like scope root? And then if we have a cons, a label, so labels we ignore here, and then we have value, and then we have the rest, right? So in this case, this must be well, I mean, we have recursive, right? Shape scope, and scope, module scope, inference scope. So this just takes the var and returns the, so this is going to be inference, var scope of the var, right? Okay, so this should, okay. Yes, and inference scope, yeah, on inference scope, I don't like this being the unite. Unite should just be TTT. I don't need this span there, because this is supposed to never fail. Unite scope. So unite scope without the span, I think, is what I want. So this is not scope unite, this is just scope, 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 right? And this is not scope unite, this is just scope, scope, scope. So in this case, what we need to do, we need to say that value scope is is, so this is a value, which means that I need to like figure out how to know the value scope, right? Value scope. Value scope is value scope value, and then rest scope is scope module scope rest. And then I need to do scope unite, value scope, and rest scope. That's what we return here, I think, right? And we have a error. This also returns scope root. Does that work? The expression has type scope T, but expression was expressed of type A. Because I probably need to like specify the type here. It should, the type should be something like this. It should be like a scope module inference scope with type T equal scope into, so value scope is like a into scope, and this returns the a scope shape, returning the scope. That's what I want, right? But now this the pattern matches values of type that, but we expect it with type T equals scope. Can I just say with type T equals scope? The type of this backed module contains variables. Yes, what's the problem? It just says signature mismatch. Oh, the signature mismatch in the label, so I'm not even getting to that file yet. No scope. Yeah, unite is without the span, basically, right? That's what we need here. Okay, the type of this packed module contains variables. Is that an error? Or are you saying that this scope is not present in the current scope? I need to say like here type scope, right? Is that? Yeah, that's probably what I need to do. Let's have a match shape. So we have a shape here. Right, so shape is of type. So we have type A, type scope. Shape is a scope shape. A value scope is a into scope. This should return scope. The signature for this packaged module could not be inferred. Are you stupid? I literally have it as the argument there. Like, it's literally written out over here. Is OCaml stupid again or something? Type A, type scope. Maybe it's because like this over here is like something with type T is scope. So in this case, that is a scope row. That's what I want, right? Yeah. So the type is this. Type T scope, a scope row into scope. Yes, correct. So rest scope. The expression has type A, but expression with respect of type scope. Rest has type A scope row. Wait, this has underscore scope? No. That's probably just for printing though. The signature for this package, the module cannot be inferred. Why not? This is a pure OCaml ritual failure. Completely avoidable. This only happens when you write module scope. And OCaml goes, cool, what is scope? No idea. So this line is the problem. You cannot pack a module without telling OCaml its module type. Yes, but I do have the type, right? That's what we have. Or are you saying that this, like, even although it's annotated here, I need to annotate it here too? We need to copy pasta. Now I annotated it, so what? Now I have a different error. The expression has type. Module, but expression was straight of type A. Oh, wait. What is the type? Hold on. Scope has... an expression was expected of type A. The type constructor scope would escape its scope. Okay, we have a scope escape here. Scope would escape the scope. Is it because I'm calling it scope here? I mean, like, can I call it scope 2? I mean, that's the same, right? That's not the problem. I don't get this. If I don't use the first class module here, then we need to be able to we can like flat this module. This is basically like multiple functions in one. That's what I'm going for here. I care about the unite and the root here, these functions. Let's try specifying the type here directly. So the type here should be a scope module into a scope row into scope is function, like that. Wait, this actually fixed it. It's because OCaml is stupid and cannot infer the types. Got it. I need to duplicate my type annotations like 10 times. Okay, sure. Let's go next. So when we have inferred, so in order to figure out the shape scope, I need to like, yeah, inferred. We need to have like module scope, which is inference. Can I just say module scope? Can it infer it? Probably not, right? It probably cannot do it. Shape scope, module scope. No, this should be like scope. New inferred requires scope, not scope. Wait, no. Shape scope, module scope. Scope shape. Which one is partial? Oh, you mean like shape scope is partial? And yeah, so like this needs module scope and value scope, I guess. So this is module scope and value scope, right? Module scope, inference scope. Scope T would escape its scope, right? Because this, okay, like you see how over here I'm not specifying the type of this module, but over here I had to. But like, what's the difference? With type T is scope. Scope is because this one is a recursive function. Type scope. Okay. And this can like unify these things now. Okay, sure. So I did not give this the full type declaration. Print. In order to print, this is a scope. A scope. A scope. Unite shape. So in order to unite the shape, unite the value, a shape inference unite, a shape, but shape has a and span, right? And scope, a scope, like that. Right? Okay, so we have a new not inferred. So in order to unite, we need to we need to know the scopes here. Unite value, unite value, Inference variable. So in order to infer as, I need to give it the function which takes the scope, which also like the unification of the scopes, right? So in order to unite shape, we need to have a module seam, a module scope, which is inference scope with type T is scope module. This is the signature module scope. Type A, type scope, scope inference scope with type T is scope. So when I infer as, I need to give it first. Yeah, I need to like give it a value scope. Value scope is just A into scope, right? Module scope, value scope. This should be value scope. Unite shape and then scope unite. Value scope, span, scope unite. So this error doesn't exist. Am I right, OCaml? No, maybe I'm not right. I don't know. Like the language server is showing me this error and this thing is not. Oh, because this is a recursive. Maybe I need to fix this first. A scope, unite a scope. If I know how to unite these things, inference var unite, I need to tell it how to unite the scopes. So this should have scope unite, which means that this also takes the module scope, inference scope with type T as scope, type scope. Can we? Unite shape. Unite shape also requires module scope as argument, right? Unite shape. Why can I not go to the definition? Why can I not go to the definition? It's literally over here. Yeah, it's also value scope. Value scope. Okay, so value scope is A into scope. And this is going to be module inference scope with type T is scope. 6, 7 on a Merry Christmas. Unite value has type span AAA, but expected of type module interpreter scope. Where this unite? Yes, unite must give the module scope here and value scope. Okay, unite value, unite shape, over here, unite shape, module scope, value scope, unite value. Is that better? This expression has type A, scope, shape, inference, unite. Yes. But expression was expected of type A inference unite. Oh wait, we want wait, what? Why is that inferred? Because B rest var. Wait, what? Where? A rest var. That's not right. we want. Wait, what? Unite shape. This expression has type unite shapes, right? Yes, that's what I want. But why am I expecting this? A unite. Oh, because value scope. This is not the value scope that I need to give it here. I need to tell it shape scope. Shape scope. Right, but shape scope is the thing which takes. Okay, so this. So this should be like shape scope, module scope, value scope. Is that right? Almost. What is the rest here? Value rest has type scope into T. Right, because rest is new not inferred. I need to like figure out the scope of the new not inferred variable, but the scope here is going to be the rest A. Right? We have A rest and we have B rest. So the scope of the new rest is the common scope of the of this one. So it's going to be scope unite. Scope unite. Scope of A rest and scope of B rest. But in order to figure out the scope, we need to pass it the module scope, right? So we give it module scope here, and we give it the module scope over here. Oh my god. So elegant OCaml is, right? Let's go next. Of list. Inferred. Module scope. Module scope. Inference scope with type T is scope. Type scope. Inferred module scope. Of list. Module scope. Inferred. Oh, there's also value scope there. Okay. Of list. Okay. Value scope. Inferred. This value scope of list. Module value scope. How much more copy pasta is needed here? Is that it? The expression has type A, but expression was scope of type AB scope. I need to like duplicate the type now, of course. A scope. Module inference scope with type T is scope. A into scope. Span. A list. A scope row. Function row. This expression type variable C. Type A, type scope, value scope, A into scope, span, list, A list. Oh, this is not, yeah, this is not A list. Okay, this is label times A list, right? Okay, maybe that's, yeah, okay. Can this work if I don't specify this now though? Can it infer this type? No, it cannot. Okay, so this is still needed. Stupid OCaml, okay. Love it. Okay, but we are now past this thing. This is the final boss. this is the all of the actual types of the language. Okay. So we have a value. Values can be inferred, so they are inferred in the let's call it var scope. We will have a new thing which is going to be called, actually, you know what, how about we shall say in value shape var. I'm just going to have the var here directly, var, so I don't duplicate it in other places. I'm just going to say that's type a var is inference var of a and var scope, right? And var scope, this must be recursive, yes. And var scope is going to be, so this is going to be interpreter scope option, I think, right? I think so. Type variant data row T. So yeah, okay. Maybe it doesn't really matter. Var scope, inference var, boolean. Well, in this case, this can be a no scope, I suppose, but I mean, it doesn't really matter here. What scope? We use type shape var. Name is name shape var. A name shape option var. And this over here is the copy pasta. So let's take copy pasta and copy paste. Like this. Unbound value object equal. Equal function true, compare function 0. Span t. Did I just remove the comparisons again? Okay, the types have been defined. That's already a huge progress. All right, now how do we print? How do we print the things? When I print a variable, we have inference variable. Let's just say var, right? That's what we are printing. Okay, that's all that was needed. And this is the actual inference algorithm. So now for inference, because we have the scopes now, in order to unite the rows, we need to have like the module scope, right? Yeah, let's first create the module var scope, right? So it's going to be inference scope, struct type t is var scope, root is none. Unite AB is fail with lock. We will need to calculate lowest common ancestor here. Let's first make sure that it's like type checks, because that's the problem. Equal AB is a ID AT-BT a option equal interpreter scope. Wait, but this is but interpreter scopes are yeah, they are equal by this, which is wrong. We just want to take their IDs, right? So we just have a function A interpreter scope and B interpreter scope into ID equal AID BID, right? That's what we want. And we have the function compare, which does the same with comparison. Okay, that's all that we need. So when we do a row unite, we must give it the module scope and then the inferred thing. Yeah, okay. So module var scope and okay, so this is type shape, right? In this case, type shape row. This is the row of what? T variant. So we have a variant, T variant, type variant. Can I go to the definition, please? Type variant data. We just have the data there, right? Let's have functions here. Let type variant data scope is type variant data into var scope T, I guess, right? So that's going to be a function data into match data with none than var scope root. If it is some data, then so this should be also recursive, right? This is the scopes. Can I do this in module scope? Can I just do this directly here? Maybe. Can I just have a recursive thing? And we call it just the same as the type, these functions. So this data is the type, and then I'm just going to say type data, right? And then we have end type. So this is going to be type into var scope, right? This must be just inference variable scope of a type variable, I think. Right, so there's like function var into, because types are just vars. That should be easy. So over here we say that this is going to be var scope dot type variant data, right? There we go. Next. A lot of this seems like not need to change. Unite is mutable, inference var unite. So this is booleans. Unification of the scope is just scope unite, or scope unite. Okay, next. Unite types, unite type shape var scope unite. Okay, wait, I'm already halfway through. Is this actually that easy? There's no way. Where's all the suffering that I usually have with OCaml? Is it gone? Is it actually Okay, inferred type. So in order to create the inferred type, though, what do we need here? New inferred. We need to say how to get the inferred scope, right? So this is just going to be var scope dot type shape, because that's based on the type shapes. Okay, so we say type shape. This should be a type shape into var scope. Okay, so that must be a function now, right? Or like function shape into shape destruct like so. Unit. So like some of these, they don't contain the variables at all. In that case, we just return root. If I have a reference, type ref mut referenced is mutable. Mut unite is mutable mut, and reference is just a type, right? So just type referenced. No, this is a little bit too many vertical bars. Is mutable is mutable into var scope. So just function var into inference var scope of var, right? Okay. Error is just root. Variant. Actually, you know what? How about this? You know, type ref x, type ref x. We're just going to have this type ref is type ref into var scope is function like so. Type variant x into type variant x. Are you just trying out OCaml? No, I have been writing it for a long time. I'm making my own programming language. It's almost ready to be self-hosted, kind of. I solved advent of code with it and stuff. I started trying OCaml a year ago. Now we all have the language written in OCaml. Is OCaml good in your opinion? I think OCaml is okay. It's not good, it's not bad. There are definitely worse languages. There are definitely better languages. But you always hate your life when you use GADTs. I hate my life because I was trying to do recursive functors earlier today, and I literally gave up, and I came up with a different solution, which leads to a lot more verbosity in the code. Well, I mean, like it's just like there's a lot of verbosity, and anyway, I guess, in OCaml, and sometimes you have to use like functors and recursive functors, and that's when I hate my life. GADTs are not that bad. That's not the like GADTs are good. There is a lot like, but inference breaks with GADTs, I guess. But it's kind of easy to fix compared to what I'm doing here. What do you write in OCaml? You're just messing around? Okay. Yeah, so my problem is that I'm making a programming language which is like very recursive, because I want to have like dependent types and stuff like that. We treat values as types, with the compiler is the interpreter, stuff like that. Everything is very, very recursive. So all the types that I'm working with can contain each other. Values can contain types, types can contain values, and like all of that stuff, you know? So like that. So like breaking the dependency cycle is very difficult. You always run into things case scope. Yeah, I don't know. I don't use GADTs a lot. I am using Dune. The only place where I'm using GADTs is basically let me show you here. Like kind. So when I'm compiling the language, I'm compiling into like 5 different things. It's either a pattern, an expression, an assigning expression, a place expression, or a type expressions. This is what my language basically consists of. This is the only GADT that I have, I think. There's also, I guess also GADTs are used for like the effects, because I'm using effects, but that's defined in the library of OCaml. And then we also like pack the GADTs into like this thing, which allows me to have type and a tag together. Is Rust better than OCaml or no? I think as a language it's better than OCaml. Rust doesn't have GADTs, but I feel like I don't need them there. I mean, I can go without GADTs in OCaml too, I guess, right? Like the GADT is the only addition in OCaml that I see that is actually adding value compared to Rust. Well, I mean, there are some other things, right? For example, in Rust, you cannot write local recursive closures. That's just literally impossible. So if you like doing that, then in Rust, that leads to more verbosity, right? But OCaml doesn't have traits, so which leads to more verbosity in OCaml, because you pass your trait implementations explicitly all the time, I guess. OCaml is definitely simpler than Rust, but you asked, is it better? Is a simpler language better than a more complex language? I think simplicity is usually bad. Most of the languages that like market themselves as simple languages, I don't want to use them, because I'm writing complex programs. Complexity needs to live somewhere, and the simple languages, they force the complexity into my code base instead of just like making me learn the language and then using the language easier, you know? I mean, it is a trade-off, I guess. But I don't know. I feel like, I guess it depends on what software you're writing. But everything that I've been writing in the last 10 years is better with a more complex language than a more simple language. Because everything that I'm writing is complex, I guess. So right now I'm adding scope information into my inference variables in order to have literally the same error that you're running into in OCaml. The thing escapes the scope. I need to make sure that the types don't escape the scope, right? Here's the simple example of what we're going to fix, and also it's going to fix my performance issue because of like stuff. But here's the simple thing that I need to fix. Here's the example in my programming language. The simple one, the inference bug over here, right? So if you look at this code, right, we have a function f, which is function taking x, returning x. What is the type of f? I don't do let polymorphism, unlike OCaml, which means that this is some concrete type, returning some other concrete type. This is not generic id function. And then I have a generic function which tries to call this function from inside of its body, giving it the generic argument as the argument, which leads to us inferring the fact that this f takes this t as argument. But that cannot be so, because t does not exist in this scope, which means that this t is escaping the scope through the type inference, which should not happen. That's the short version of it. But we also use the we will also use the scopes for, like I said, the other thing which is more important, fixing the performance, because right now after a couple features that I added recently, performance sucks because I'm doing too much substitution, and in order to not do the substitution too much, we need to do the substitution based on the scope. So it's like I'm going to fix two things at once is the idea, unless I'm wrong somewhere and it's not going to be fixed. All right, let's go one by one. Type variant is type a variant into var scope. This is a function type variant, name and variance. Name is optional name, so this should be like this should be unite optional name name. And variance is the row, right? Yeah, variance is the row. So this should be a row row scope variance, but that requires us having module var scope, which means I guess that after all this does not live here. And it will live in another place, sure. And so this is going to be inference scope. But I'm just going to have like another one, module var scope is struct, like so. And now we can refer to the previous var scope, which I'm also just going to include here, I guess. Yeah. The expression is type T, but expression was have type var scope. Well, yeah, because this should be inference var scope with type T equal var scope, right? Okay. Nice. Optional name, row scope. Yep. And type tuple is type tuple into var scope function tuple. Is that what we have there? Tuple, type tuple field tuple. Can I say just something like let scope be ref? I think we do tuple to sequence, and then we do sequence. We need to do folding here. Tuple to sequence, fold. Fold has like the function that takes a accumulator and the thing, and then I give it the accumulator, right, which is going to be a root. So we start with the root scope. Wait, no, we don't start with the root scope actually. No, that's actually not correct. Wait. I need to not wait. Well, I mean, yeah, we need to unite here. I just cannot start with the root scope, I guess. So what we're trying to do here is we are trying to figure out the scope in which the type exists. But that's not correct logic, I think, because we are not trying to find the common scope of all of the fields of a tuple. What instead I want? What do I want here? I'm trying to figure out the scope of a tuple. What features would you say makes a language a good language? I don't know. All of them? Why would you not have a feature if you can have a feature? Isn't the lack of a feature the what makes a language a bad language? That's literally C++. Well, I mean, but no, yeah, people think that C++ is bad because it has too many features. My thinking is that C++ does not have the features which would make it a good language, such as type safety, or I mean not type safety, like memory safety, like from Rust, for example, is one of the features that is really missing in C++. I mean, so there are some features that can be implemented using other features, right? That maybe is the problem in C++. I'm not really sure. I'm not using C++ much. But if a feature can be removed, but it can be implemented using other features, then yes. But sometimes you're literally just lacking the features, right? So you need to have all the features possible without having every feature implemented, but you make still the language simpler by having some features be compositions of other features, right? So that would be the that is the language that I'm trying to make here. I'm trying to find like the minimal thing that we would be able to compose into everything, because I want to be able to do everything. I currently have some features that can be like removed and like replaced with a single one, but so like I can understand how C++ got in that position, because like you start with a simpler implementation, then you like grow things, but like but eventually you just want to remove the previous implementation and like replace it with a simpler one, you know? That's hard to do. Yeah, what I'm doing here is hard for sure, yes. What I'm trying to do is hard. So right now I'm focusing on just the high level aspect of the language, but I want the language to be able to be used in low level contexts too, right? And stuff. Cast was already quite complete before higher candidate types. Yeah, I guess. Well, I mean, what do you define by complete? We can make like a very simple language, like the first time we calculated something, like I had the guess a number game, like in the first week when we started working on the language or something, or at least like in this rewrite. Can I see where you use your GADT or examples of it? Just want to see how you annotate and how the type checker infer the types. Hold on. Maybe in the LSP. I guess this would be one of the examples. So this over here is the GADT. And we need to make sure that this and this is the same type. Have you seen like this? I think I remember when I first struggled with GADTs is that I didn't know that this syntax existed. Do you know about this syntax? So this is like if I write the complete function signature, it would be something like this: a into a compiled kind into a into inner compiled handler into unit, right? There you go. I have these issues because I'm working on other parts of the language right now, I guess. But you, I think, have to do it not on the type ascription, but on the actual definition of the function. For some reason, I don't know why. But yeah. So basically, for your generic like argument that you are, which is the argument of your GADT, you have the type argument in your function, and that's how you annotate when creating the function. All right, does that make sense? Maybe you can show the example of the code that is not compiling for you. If you show me the example that's not working for you, then we can try figuring it out. You can derail me all you want. Type function. Yeah, so the problem is, what am I doing here? I am trying to figure out the scope of a tuple. So like technically all of these things all of the fields of a tuple must have the same scope as the tuple itself, right? That is what should happen. So I shouldn't even like iterate over all of the fields of the tuple, because that's the job of the inference. The inference engine should guarantee that they are equal. But in order to figure out the scope here, we just get the first field. Well, I mean, some of them can contain no variables, right? I guess it's the deepest scope, probably. Right? So basically, let's say that I have something like this in my code. I have a tuple. So we have a generic T, and this returns like int32 and t, right? That's the type. It has a field int32 and it has the field t. But so this t is only existing in the scope of this generic, right? But int is not having any variables, so this is in the root scope. So what is the scope of this tuple? The scope is the same as this t tuple, which means it's not the lowest common ancestor of the scopes of this and that, but it's the other. It's like the it's the deepest of the scopes, but these scopes may only be nested, I guess, of the fields that we have in the tuple, right? Because if I have like I don't know, t, which contains inside of it u, right? int32 tu, right? Something like this. So the scope of int32 is the root, the scope of t is this scope, and the scope of u is the inner scope, right? So we have like these nested scopes. When they can only be like nested into each other, but that is just has to be guaranteed through the inference. And in order to know the scope of the tuple, we just take the deepest scope, I think. What is this? Activate Linux overlay? Well, it's the overlay which is telling you that I'm broke and I cannot afford the Linux license. All right. Yes. So over here, so we need to have like the deepest, right? Deepest, and over here is also deepest. Like I'm not doing the unite then at all. Over here, unite. Yes, unite should not be used here. I feel like I want to say let root be or scope root. Just so that I don't use it on accident. I want to use the root, and I want to use the deepest. Deepest, A and B. So this is going to be match A and B with none and none, then none. If it is none and some scope, or some scope and none, then it is some scope. And if it is some A and some B, then we just check the what does Linux license even mean? I don't know. There's Linux license. You just say license you gotta activate when you install Linux for the first time. Yeah, there you go. Type A and B. So yeah, this and this. This is LC. So this is the lowest common ancestor of two scopes, and this is the just the deepest one. And they must be nested into each other. Like we can, yeah. When we calculate the deepest, we we also like check that the one is the parent of another, is the ancestor of another. If we want to have more guarantees that my code is correct, I guess. So over here we have accumulator. So we start with the root and then we just fold. And over here we have the tuple member. Member and type tuple field. Okay, member. I don't care about the member. And then we have field here. So field has a type and label. Field has type and label. We ignore the label. And we just say, so this is like type. So this is going to be field type. we say deepest of accumulator and type field type, right? Like that. Yeah. The following labels are not bound. This is OCaml inference being bad again. Type tuple field. Okay, and name is also optional name. So I guess we can start with optional name. So optional name, because names can also be inferred. And optional name is optional name into var scope. This is just function. This is just variable inference var scope var, I think. Same with not optional name. Okay. All right, now we have type function. This is type function into var scope. That's just going to be function. So function has the argument and result, right? And we just return the deepest of the scopes of the argument and result, right? That's easy. If I have type generic var scope, generic also has argument and result, I think, right? But for generics, the argument is a pattern, not a type. Yeah. Do I get for the pattern? I mean, pattern has the type, right? So I need to like, yeah, I don't care about the things that we bind. So we just say deepest of like type argument data type and the type of the result, like that. Type opaque. Type opaque. Var scope is function. What is type opaque? It just has name. So we just say name. Maybe I should not call this the same as the type. Scope. Let's call it like scope of type variant data, right? Scope of a type. Scope of type shape. Scope of type function. Scope. We're just going to like call scope name here. I mean, scope of maybe is a better name. Should I call all of this into scope of? Scope of, sure. Okay, so now we have scope of type unwind token, unwind token into scope, unwind token. type unwind token. That just has a result. So this is going to just be a scope of type result. Okay, and now we just have the blocked values. Now we just have the blocked values. Scope of blocked value. This is blocked value into scope. Blocked value has shape and types, right? So this is going to be deepest of scope of blocked value shape, and scope of type. And scope of blocked value shape is blocked value shape into var scope. That's just going to be a function. Shape destruct. I think that should work. If we have a binding. Wait, so if I have a binding exists in the scope. This is like the important thing here. So bindings must like remember the scope in which they are created, right? Which I don't do right now. Okay, just have fail with a lock here. So we will see this panicking later. Let's fill the other parts first. If I have instantiation, x scope of blocked value instantiate x scope of blocked value claim ref x scope of blocked value field ref x scope of blocked value instantiate blocked value instantiate var scope function generic argument. Generic is a blocked value. This is just a value. So we say scope of blocked value generic, and we say scope of value argument, and we say the deepest. And scope of value. Scope of value is just value into our scope. So it's going to be function, variable, and type into deepest of inference variable, scope of variable, and scope of type. Okay. Scope of blocked value claim ref. Blocked value claim ref. I guess claim ref. This is just scope of blocked value, I guess. And field ref. But field ref is existing, right? Field ref. Blocked value field ref into var scope. So there's going to be object and field. Field is blocked. No. We don't have object. What is this? Oh, we have object ref. Object ref. And the field. And field is member. Okay. Member, tuple member. Tuple members, they don't have the thing, so we just have this thing. So we just say scope of blocked value object reference. Okay. Okay. Unbound value scope of type ref. Scope of type ref. It's literally over here. Oh. Oh. And let's track. Okay, so now over here we have scope. Oh wait, hold on. Since this is a module scope, I don't need to prefix everything with scope of. We just do of, right? We already have the namespace in here. We just do of type. So then over here we're going to say scope of type variant data, right? There we go. Okay, let's go next. Inferred type. New inferred value. This requires the scope of type shape. Okay. Inferred value. New inferred value of shape. So this is going to be scope of value shape, which I have not declared there. Let's do that. So we have a value, but we don't have a value shape. And the value shape, this is value shape into var scope. That's going to be function shape into shape. Let's destructure that. Function unit root boolean root int root int 64 float char. Can I I also want to type annotate this just so that we know that this doesn't contain the variables in case I change this later for some reason. If I have a reference x of value reference x of value tuple x of value variant x of so this is a type, this is just going to be of type function x of value function x of value generic and value native function ast just has asts don't contain the variables, so we return root unwind token x of value unwind token x target a value target x value context type x compiler scope is just compiler scope root opaque of value opaque locked of blocked value blocked error is root. Okay, we just need these functions. And Okay, a value ref. A value ref is having mut and place. Place. Place can contain the variables inside, but does it change the scope of my reference itself? I don't know. I feel like we just say of is mutable mut here. Wait, is that not is mutable? Oh, this is just a boolean. Is this just root then for references? Unless it's the places. We need to. I need to check this. If place can be ignored here. Not sure. So then we have the value tuple. And type. This is going to be deepest. Well, I mean, we're just going to say tuple to sequence, fold, function, accumulator, member, and field. This is value tuple field into something. Accumulator is going to be of type tuple type, maybe. Value tuple field. Oh, we have place, span, and type field. Place, span, and type field. Of field, deepest ag of field, let of field be. I guess in this case I actually read the place there, right? So should this be of place then? Where's my syntax error? Where's the syntax error? Do I not close the something? I don't see anything that's not closed. Syntax error. Beautiful error. And I need it in here. There we go. Can I just say, like, let's just do this here, of and of value tuple field into var scope function. This is that into this. So this is going to be a function accumulator field into deepest accumulator and of value tuple field, right? Deepest. What is this here? This expression has type member value tuple field sequence. The expression was expected of type value tuple field sequence. Fold left. Fold left. Yeah, this over here, right? We have member and field, right? Like that. This member is tuple member. Does this require whatever? So now we have of place. Maybe we just call of place here then. So what is of place? Of place is a place into var scope. So whatever is stored in the place, right? Function state of place state. There's also type, ID, type, mud, and state. So it's going to be of type. Of place state. Of is mutable mud, because this is wait, this is place mud. No, forget about it. We'll just do this and we'll do deepest. Of place state. So then there's going to be function. Places can be uninitialized or moved out, or occupied with value. Then we have a value. Wait, isn't this thing also recursive? Because we have recursive things. Of course, this is going to lead me to infinite recursion. I need to do all of this with a recurse cache and stuff. Of course, we're going to have infinite recursion here. We'll fix that later. Value variant, label, data, and type. Label, data, and type. Deepest of option of place data of type. Of option is something like works for all. If we have a var scope. Then we have a option into var scope. So this is just going to be function of value of x, I guess, into function none into root and sum x into our xx. A value function. Value function has type and function. Type and function. Value untyped function. Well, I mean, untyped function, yeah, they have IDs and yeah, whatever. Or not, whatever. They have the captured scope here. I don't know. Type. F type, function type. Value generic. Function. ID. Name. Function. This is untyped function. And type. This is type generic, right? Okay, so there's going to be deepest of name of type generic type. Oh, this is of name shape then, right? And I don't have of name shape. And of name shape var scope is function. Can cut AB deepest of name shape A of name part B. Instantiation name instantiation X of name instantiation X of name part name shape. It's just name part, right? Of name part it seems like these don't have the anything that needs to be done. Of name instantiation generic argument deepest of value generic of value argument. All right, almost of type value variant of type variant of a native value function these ID can be ignored, name must be, implementation can be ignored, so we just say deepest of name of type function of type function type. Unwind token has ID and result type. ID result type of type result type. On value target. Name string can be ignored. This is going to be root. Value context type. ID and type of type. Value opaque. Type and value. Type and value. This is going to be of type opaque type. Of name. Name is a string here. Native function. Oh, native function has a name which is string. Then we can ignore it and just return this thing. Okay, now we go down here again. A new not inferred type. New not inferred type requires the scope. So now when we create a new not inferred type, we must give it the scope, which is we must give it a scope, right? New not inferred scope. There you go. So scope is the variable scope, right? New not inferred value. Also scope. Scope. New not inferred type scope. Okay. So we say that type variable once inferred, we infer value shape. Infer as is the thing that needs, right? This needs inferred scope, and it needs unite scope. Inferred scope, since this is the what? This is the type shape, right? So it's going to be scope of type shape, I think, and unite value shape, and like var scope unite then. Scope of type shape, a unite value shape. The value unite value shape has type value shape unite, but expression was expected of type shape unite. Wait. Because this is my original variable. This is my original variable, which is the variable. This is the value shape, right? Alright, so this should be our value shape. There we go. Okay, infer value shape. Infer value shape. This must give me the scope. 2, right? In addition to span, because we're creating the new not inferred type in this scope. So infer value shape requires scope. That's the same scope in which the variable was created. Okay. Sure. New not inferred value of type. This also needs scope. New not inferred value scope. But we just unite the type like that. Okay, sure. What is this? New not inferred value of type scope. I do have scope here. Okay, good. Type of value shape. When we create the new inferred, we just need to give it the function that takes scope out of the thing. This boolean var scope. I mean, this is boolean, right? Shouldn't this be just scope of boolean? You know, but of boolean, this is bool into var scope. Isn't this just function that returns the root? Okay, new not inferred value span scope span scope span scope span scope span. All right, the inference is done. No way. Apart from the couple to-dos of actually calculating the deepest and the lowest common ancestor of the scopes. New inferred value. Inference variable scope of name shape, right? New not inferred. This must have scope as argument. New inferred. Inference impl scope of optional name. This expression has type t var scope inference var, but expression was quite of type name shape option var of optional name. That's optional name. Oh, optional name shape, I guess. So which is basically of option scope of name shape, right? There we go. New not inferred, that takes scope as argument. Okay, this module is compiling. No way. Now we are back to the interpreter. Oh. Now we are back to the interpreter. So this is the substitution. This is the important part. So now when I'm doing the substitution, creating the new not inferred value new not inferred. Well, I mean, sub var. I think that's totally fine, actually. Sub var. Why can I not go to the definition? Can I reload OCaml language server? Why does OCaml language server not work? Sub var. So this should be what? In order to get the variable. So these variables now have not only shapes, they also have. Can I just say var here? There we go. That's what I can do. But new not inferred not only takes the span, but also the scope, which is var scope, right? Yeah. The rows also include now the scopes. var scope, which is just the variable. Like that. Type new not inferred has span scope. Oh, it's a span first and scope next. So the order of these named arguments matters. Span scope. I'm not sure if it's like... I just need to fix the other one. I want scope to be the first argument, so type new not inferred, new not inferred. Yeah, this should be like scope span, scope span. Okay. So now, in order to unite the shape of a row, what we need to give it is the module inference scope. So we will give it the module inference implementation dot scope dot var scope. Uniting shape also needs to get the scope of the inferred thing. Right, so over here we need to have also scope of, this must be a into var scope, I guess. So this scope of value basically. This must be in parentheses. What just happened? Where's my cursor? Row new not inferred requires span and scope. I want scope span. Substitute type variant sub row. So sub row now requires the other argument, which is scope of value. Scope of value, since these variants are type variant data, so this should be inference impulse scope of type variant data, right? There you go. Sub row shape. Inferred span. Inferred. So row inferred requires the scope, so we give this over here module var module inference impl var scope. A row inferred also requires value scope. Scope of value. Need it here. Did I not just edit? Yeah, I did edit. Scope of value. It costs $200. What? The Linux license? I don't have that much money. That is too much. Sub-row shape. Dun, 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 dun. Scope of value. Need to give it this argument now. So sub-row scope of value like that. Okay, we are getting somewhere. So now the actual substitution of the variable. This is the only code that is having some logic, right? So previously I was remembering if I have already substituted as the thing in the scope, and then I return the original value. But what we need to do is we need to not do the substitution if what? So we have the current state. We have the current state. What's my logic here? The state is the state in which this variable should be writable. Maybe I should have like the target scope or something. I think target scope is something that makes sense. What do I even take from the scope, from the state? Can I replace all states into target scope, which is var scope? Can I do that? And so now instead of state, everywhere we say target scope. Sub value. And this should be like target scope var scope, because I don't need the full interpreter, do I? Well, I don't, but I need to like look up the values of the variables, right? Hello, Tepco Wild. How's it going? Better than earlier today. I am actually making progress, I think. I'm not sure though. It's a huge change right now. Let's see, git diff stat. That's the other one. That's not what I'm working on. Cast line cast over here. Let's see how many lines of code did I try already. Not that much. Well, I mean, I guess I did not add. Git add dot maybe. Why is it not showing me the thing now? Why is git diff stat not showing anything? Cached. There we go. Yeah, I guess 617. Not that much, right? It's I gave up on like the other attempt of refactoring, and I'm doing like this other one. If we look at my other attempt though, I gave up after after removing 2,000 lines and adding 5,000 lines of code. And I don't think I can make more progress there. I mean, maybe I can, but I'm stuck trying to figure out how to do stuff in OCaml. Okay, so what do we need to do? We have the target scope, and we need to not substitute basically. If the target scope is well, if the scope of the original value, is an ancestor of the target scope, then we don't care about substituting, and we don't need to do anything, right? So we don't have scope ID. We instead say var inference var scope. We can get the scope. And this should be like var scope is ancestor of target scope. Okay, now what is target scope? Module var scope is inference impl var scope. Maybe I should just re-export it here. Module var scope is inference impl var scope. Yeah, I think that makes sense. So we need to have the let's not do the type here. We need to have the function is ancestor of child ancestor, right? So return boolean unite a t b t t is the LCA deepest Okay, so it looks, yeah, substitution. Yeah, I actually still need the interpreter state. So I need both interpreter state and the target scope, I guess. So maybe like, yeah, maybe we rename this. So target scope. I can just say that target scope is not the var scope, but is interpreter state. Maybe we just name it instead of state to target scope because we are targeting the scope of this interpreter state, I guess. Wait, but shouldn't this basically... Wait, hold on. But then whether I substitute at all could be here. Or not here. Wait, but I'm substituting, but then I should be looking up these bindings, not in the target scope, right? I should be looking for those in the original scope. Right? Okay, so, okay, hold on. We have two things. We have target scope and we have interpreter state after all. Right? Mm-hmm. Maybe I can say like state is a substate. Where a substitution state contains both the interpreter state and the target scope. How about that? You know, I'm just going to say that type substate is interpreter, which is interpreter state, and target scope is var scope, right? Like this. So when I instantiate, this requires like running code. We say instantiate state dot interpreter. Over here, state interpreter scope for finding the variable. Okay, and then we are back here. So how do I substitute the variable? We see that if this is the ancestor of state target scope, I mean, it's not ancestor. Like, is ancestor including the scope itself? How do we call this function? Is ancestor or the scope itself? How to call the function that checks if node is ancestor or the node itself. In JavaScript, we just say node contains. Yeah, I guess contains is a... yeah, sure. Contains is a good name. So the scope contains the other scope, right? Is ancestor of means that it contains the other scope. Is this contains the target scope? Yeah, I like that. I think. Self or. I think contains makes sense. Well, I mean, self or what? Self or is not a good name because or what, right? This should be self. And what is self? It's just this scope contains this other scope. That's literally what I want to check. Contains scope, this, and the scope contains itself, basically. All right, we have the tree of scopes. Let's remove the logging. So we create the temporary new not inferred. This is created in scope, which is target, which is state target scope. So we create the substitution directly in the target scope. We don't say that it's a remember sub because now the inference is aware of the scopes. That's just logging. A remember sub is not longer necessary. And we say inference var unite. This requires you uniting the shape and uniting the scope. So it's just like var scope unite. Okay. Wait, is that all? Is that all? Is that all? This might actually be all. Of the substitution. Substitute type is some subtype. The value subtype has type span, yeah, span state. So state is substate, inference simple sub. So this is going to be state. So this is the substitution state, right? Substate. Substate must be. What do you think teach you about yourself about CS? I have never seen that before. If you're a self-taught engineer or a bootcamp grad, you owe it to yourself to learn computer science. Thankfully, you can give yourself a world-class CS education without investing years and small fortune in a degree program. What is this? This is just just links about how do you learn yourself. I mean, it's a collection of links of what to learn, I guess. Macromedia Flash. I remember that. I don't know. I feel like you teach yourself, you just figure out what you want to do, and then you look it up of how to do the thing that you want to do. That's all, literally. That's how you get self-taught. Right? I need this subtype. So like this type should be declared somewhere else, maybe in the inference here after all. Let's make this be in the types. Sure. Yeah, so now in okay, this is the one, right? When we unite the generic types, subscope ID, this over here is the interesting one, right? Do you think is good curriculum or just need to learn like web dev and algorithm and data structure? I don't know. I have not read that curriculum or... You can try it, see if you like it. If you don't like it, try something else. There's like 1,000 ways to learn, I guess. See what works for you. So do you go to school or learn how to code by yourself? Well, I'm not going to school anymore. I'm too old for that stuff. But I would say that in school, I barely learned anything. I did learn a couple things in school, but most of the things I just self-taught. Yes. With the exception of like a lot of the algorithms and data structures, I did because I was doing. I know because I was doing the competitive programming in university. But a lot of the things I was self-taught because I was just trying to like make games, right? I'm working on this game over there. You should wishlist it, by the way. But yeah, you just basically like try to make games. You look up all of the things that are necessary to make a game, which is why I know, like, I don't know, linear algebra and stuff, for example. I don't know. How did you start? You just look up how to do things that you want. That's all. And you just try, and I mean, like, you only look things up if you are stuck, also, is how I learn, right? So, for example, over here, I'm making my own programming language. I don't really know how to make programming languages. I know no theory about making programming languages. I have not read books about it. I'm just making it. If you want to apply to a job, do you not need a certificate? I was never asked certificate when I was doing job applications, but I have not been doing a lot of job interviews, so I don't know how many of the employers actually care about the certificate. Usually, I would expect the employers to care about like your skills than the certificate. Certificate means nothing. You can get the certificate without actually understanding the things. Then it's a certificate and 6 years of experience in your country, in Iraq. Well, probably not every company, right? Too. It depends. I mean, I guess if it's not difficult for you to get the certificate, go get it. All right, so over here, I'm creating the two. I'm uniting the two generic types. So I need to substitute bindings with other bindings. So what am I going to do? My state. I'm creating the new interpreter state here with having these other locals. Okay. So I'm going to have the state which has interpreter, which is state. What is my target scope? But my target scope is still the original. Yeah, what is my target scope when I'm uniting here? Probably just the common scope of the two things, right? Because I'm uniting them. As A, as B. So can I say here that common scope is var scope unite scope of type generic A and scope of type generic B. So we say that target scope is the common scope. Yeah, that makes sense. Pattern match. So this is interpreter. Wait, I have done the substitution of the bindings. Okay. So pattern matching. Let's say binding. So this is a new inferred mutability of a reference. So this should be the scope. Or no, this should inference for. This is the scope of the inferred one, right? I should probably like extract this into what is the type here? Is mutable, right? I just say is mutable, new inferred span much. That's probably what I need to do. And the types. Module is mutable. Type T is mutable. That's new inferred span is var. T is var is inference. Var new inferred span. Inferred. And this should be scope of is mutable. feel like it should still be inside of the var scope. Module var scope. Inference impl. Wait, this is types. I cannot do that here. It must be not here. It must be in cast types over there. Scope. Non-bound module scope. Yeah, I think it should be var scope here. Let's unite these things after all. Oh wait, I cannot. And do it here. And module var scope is struct include var scope, right? So we just extended with this. Multiple definition of the module name var scope. Names must be unique in a given structure or signature. Fine, scope. No, let's say var scope. This is going to be like var scope impl. And we'll say over here that scope is going to be var scope. Inference simple scope. Var scope. The expression has type T var scope inference var, but it's going to have type bool var scope inference var. Wait, it's mutable. Oh, because this is of boolean? Okay, sure. Okay, this is the interpreter. Interpreter, this is the substitution, and I feel like the substitution should always be happening or whatever. New state, new state, new state is new state. Can I have here the substate? So the target scope, so I'm trying to call a function. When I'm calling a function, I need to like substitute from the inner scope. Right? But the target scope is my parent scope. So target scope is just going to be state.scope. Some state scope, because this one is optional. So state is sub state. So whenever we call a function, we need the result of us calling a function to be writable in the call place. So we need to substitute the result evaluated inside of the function. Yeah, that's what we're doing here. Okay. New not inferred of type. So over here instantiates the result. This is just going to be scope is just say scope. Just say scope is state scope right? Some state scope. This is var scope t or whatever. And so when I create the new not inferred, I always create it in this scope. There we go. All right, I'm so close. Evaluate place. Whenever something is not inferred, we just say that scope is the scope. Scope is some state scope, I guess. That's what we always do. Substitute type. But why do I substitute the type here? State is just going to be interpreter, which is state. Sub target scope is state scope. Is that what I do though? I'm not sure. Let's call it sub here state. I'm not sure if that's correct, but like sub here is state into substate, function state into this. Sub here state. Normalized binding at index. I feel like normalized bindings. Is that used? It's not even used. Remove it. Okay, result type. When I evaluate this state, this should be a sub here state, I think. Type expression native state sub here state. Unwindable sub here state. Substitute value. This is a constant, so we substitute here also, I think. Result type new not inferred. Scope is state scope. Okay, over here, row of list. A row of list requires now the module scope, so we do module var scope here, and also it requires the variant, so it's going to be var scope dot of type variant data, I think. Okay, so this is also row of list. This is type expression variant. This is type expression union. This should be the same thing, basically. Of list module var scope of type variant data. Okay. What is this result? Result is scope. Okay, result. Because type new not inferred, scope is some state scope. Dun, 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 dun. So get field is get field. Get field should be, so state should be, wait, what? Get field. Yeah, get field is the substate. Wait, hold on, what? Get field substate. It should be just state, no? Interpreter state. If I make this interpreter state, yeah, this is interpreter state, and this original state claim ref is also interpreter state. It just means that over here I say that state is state interpreter, right? And this is state interpreter. Okay. Okay, we're making progress. Native function name type new not inferred span. So this over here, what is the span? Native function string type value function type. Okay, we have type here. So the scope should be the same as the scope of this type, right? Scope is var scope of type, and we give the scope here. Compiler. Okay, we are now at compiler. When I find binding, this is a compiler scope. Find binding. This is creating a new binding just for error resilience. So this doesn't really matter much. But the scope here is going to be what? Scope can be anything, right? So I think this should be beep, 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 beep. I give it as an argument. I give it the root. The root is not exactly correct though. So what this is doing is when in the code we are trying to use the variable Nermad, hello, what's the language I'm using? This on the screen is OCaml. This code over here, this is me trying to find the binding. So I'm trying to find a variable in the scope, and the variable might not exist. So when we write code like like I don't know, a plus b, right, and a and b are not defined in the current scope, we want to have error resilience for the language server reasons and stuff. So we are basically creating a fake variable with new not inferred type. That's what's happening. So from scope, I guess. Scope, from scope. Maybe I'm just going to give it the scope here also. From scope, var scope. From scope. Let's do that. OCaml, yes, this is OCaml. What are the pros of this language? What's the pro of any language? It's the pros is like that it's a typed language, for example, right? Not all of the languages are typed. Statically typed. It's a statically typed language with a pretty good type system, I guess. That's its pro. Some type systems are better than the others. for me. For me, like the best thing here is that it's a language that's compiling faster while still not having a completely trash type system like some other languages. You're back, Penguin Operator. Welcome back. So I want to catch many bugs at compile time. That's why the good type system is good to have, right? So the more things are enforced in the type system, the better, basically, generally. So ideally, I would write something like Haskell and not OCaml, but Haskell has a lot worse compile times, which is why we're not doing that. So it's a trade-off. We're trying to find like the good spot here between the good type system and fast compile times. What I'm trying to make is a language which does not have to make that compromise that much, I guess. I will try to make a language that is both compiling fast and is having the type system. But I'm not sure if that's like even possible. Maybe there is going to be a trade-off anyway. Typed languages help to find error quickly. Yes, because you find the error before you run the program during compilation time. All right, optional name, new not inferred. This must have the scope. So what's the scope of the new things that I'm creating here, right? I'm saying tuple type. This has okay, let's just say scope, which is var scope t, sure. Let's just have the scope as the argument. Why not? So type new not inferred is always going to get this scope as the argument. Okay, it looks like that is working. Just give this thing this scope. Expression placeholder. So like normally over here we have a placeholder. Yeah. So this not inferred is the scope is going to be state interpreter scope, I guess. Right? Some state interpreter scope. Can I say like var scope state? How about that? How about we say that? Is there a common? What do we open here? Compiler types. I don't know. Let's say here something like var state. This is going to be compiler state. I don't have the compiler state. Wait, what is compiler? Oh, just state. Just say here var states var scope. It's going to be t into var scope t function state into some state interpreter scope. State var scope state. There we go. That's what I'm going to do. New not inferred. Scope is state var scope state. New not inferred scope. Scope. Let scope be state var scope state. scope. What's inferred mut? New infer. Oh, no, inferred does not need the scope. This is infer. This is mutable, right? So this is just is mutable. Dot new inferred span mut. Okay. This also. Oh, and this is a new not inferred, right? So this is mutable. New not inferred scope span. Last new not inferred scope span is var is inference var new not inferred scope span. Okay. Scope new not inferred scope span. New not inferred scope span. What is this here? Type. What is type? Type is new not inferred scope span. No, new inferred does not need the scope. This is just mutability. This is mutable new inferred span mut. There we go. Tuple type. Scope. Substate. What do you try to fix? Well, I can give you a concrete example. Well, one of the things that I'm fixing is performance. Because this, like, the scope information on the inference variables is going to allow me to do, like, certain things less. And do it as an optimization, but it's also going to fix the inference bug. If you... This is the very simple example. This is example in my own programming language. So the thing here is, let's see, what language do you know? Let me try to write this in the language that you know. What language do you know? Are you... I mean, this is probably like readable for you anyway, but let's do it as an exercise. What language? Rust. Oh, you know Rust. Okay, nice. Let's use imaginary Rust though, because Rust does not allow this thing really. Because Rust requires you to annotate your functions, right? So let's say that you have a function f which takes x and returns x, right? That's what we have here. So we just say that this must be inferred, right? Rust does not allow the inference here. but we allow inference because I want, you know, because I want. So let's use underscore here for saying that this must be inferred, right? That's our function. And we have a generic function. So this is a generic function which takes x of type t and returns, like, what we want to infer it here, but I guess it doesn't matter, it returns t. So the body of the generic function is just going to call function f with argument x, right? So you have a generic function which is calling a regular function which is not generic, right? So so the question is, what is the type of f? Like, how would we infer this? So basically we are saying here that over here the function f is being called with argument x of type t, because we have annotated it here. This is inside of a generic function, which basically leads to us saying that this function must take the argument t. But the argument, but if we just write t here, then as you can see, t is not available in this scope. T is only available in the scope of this generic argument, of this generic function. So this calls to us to this leads to the inference variable to escape its scope. It is kind of very similar to the borrow checker, because in the borrow checker you literally have the same thing. Let's say that this is as a lifetime, so this is a lifetime, right? And this function takes this as a reference to some lifetime x, to some lifetime I32, for example, right? So so this is like a reference with list lifetime. This like returns a reference to this lifetime I32. So you just call this function, right? So this lifetime must be inferred here, and we are saying that list lifetime is the same as this lifetime, which leads to lifetimes escaping, which leads to the borrow checker complaining. It's very similar. But we have like it's more general than just for lifetimes, right? The types can escape because like there is technically no difference for inference between lifetimes and types. So types can also escape, and that's what we're fixing in terms of a bug. But this also, like I said, will allow me to perform the optimization of a certain thing. So hopefully this is going to be done relatively soon, as I am actually making progress, and we can work on other parts of the language. You wish as a compromise Rust would allow full inference for private functions. Also, I wish Rust didn't require that you write out. Well, so like because Rust requires like the type annotations, that also simplifies the type inference algorithm a lot. So yeah. Yeah, requiring the annotations simplifies the inference a lot, I would say. Also, you wish Rust didn't require that you write out the types again in the impl of a trait. The trait already defines them. Yeah. The argument is maintenance. Rust's inference engine can do it, but they deem well, I mean, yeah, you can, but it still is making it simpler. Yes, maintenance is good thing too. Yes. But there are some things that they can actually not infer. For example, the presence of the lifetime argument is inferred purely on the syntax, which you can, like, if you use Rust, sometimes you can do this in the closures, because Rust does the inference for the closure. So when you say let f be a closure which takes x and like does something with it, right? If this is a reference, if you do this explicitly, then you know that this is actually having a generic lifetime argument. But if you don't do this, then the Rust cannot infer it, and it will use a concrete lifetime instead of a generic lifetime. So that's one of the things. If you do have a more general function for the impl, you can use the general function instead of specific signature that the trait imposes. What? If you had some type parameters. I think I have impl trait params. Well, I think so. In my language, the way it's going to look like, so I guess you're complaining about this thing where you create struct foo t whatever, right? And then you need to like impl foo t, right? Like, why are we duplicating this thing here, right? So I think in my language it would be something like that. You say that foo is t, and then you like you say that the type, the actual type here that we return the type, because this is just a function, and then we can implement t with like whatever. I don't know, we call this maybe, or like self, and this is like a type, you know. Does that make sense? So it's kind of similar to how in your other languages you like you have like your class foo, I guess, and then you have all of your like methods here too. This would like have the methods, I guess. This is the type definition, but you can also do this from the outside. So you should also be able to do implement foo like int32 in addition still, but you can also do this in line. Maybe like this should have some shorthand syntax though. I don't know, but this is just a syntactical issue, so I'm not really thinking about it too much right now. New not inferred scope span. New not inferred scope span. A row inferred. Module var scope. Value scope in this case. T variant data. Var scope of type variant data. The point of needing the trait in the first place is anything that is the generic doesn't need to see the definitions. The trait defines everything that the user of the generic needs in its entirety. For example, type checking can be done completely earlier and then just flashed in later to conjure passes. New not inferred. Scope. Apply. New not inferred over here in the scope. Native inferred scope. I think I've not used Rust for so long I start forgetting it. Forget that infiltrate params introduce a type param. Type new not inferred. Scope. I just had scopes everywhere. Type never. I just knew not inferred. Scope. Sure. Type inferred. Hold on. What? This over here. Scope. Can you provide an infiltrated that is more general in terms of lifetime? Is there a way to use a more general function? What? I didn't know this can be done, by the way. I guess this is static and this is working for all lifetimes. But I guess technically, since this is for a lifetime, we don't care about the lifetime at all. So this is, yeah. You can provide. Let scope be state. Var scope state. Tuple type scope. New not inferred scope. Mute is mutable. New inferred span false. Reference is in a data type. Type inferred. New not inferred. Scope. Scope is our state. Scope state. Tuple type scope. New inferred. Is mutable. New inferred. Span false. A result. New not inferred. Scope span. If I bring a lifetime to the return type, the variance flips, so I could make an example. Yeah, I understand. Yes, because of the variance. The variance is different. for the argument and the result type of a function. New not inferred scope. A new not inferred scope. This is row inferred. This takes module var scope. Value scope is var scope of type variant data. New not inferred scope. Core syntax, new not inferred. Okay, we're very close to being done, but I think this is still going to require a little bit of time. I need to end the stream. I've been streaming for a little bit too long. I feel like this is going to work though. So now let's take a look how much code did I touch today. Git diff. Okay, unstage all of that. Not too much, just 700, just 1,000 lines. Just 1,000 lines, not that much. All right, let's see. So batch copy is like making the compiler now too. Apparently. Nice. Prolog.
I deleted from your code.
That's a programming language, right? Init encoder, not plain, plain peak. Yeah. Alright, see you guys next time. Thank you for watching. Bye.